الحمد لله رب العالمين، والصلاة والسلام على أشرف الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. صاحب المعالي محافظ الهيئة السعودية للمواصفات والمقاييس والجودة الدكتور سعد بن عثمان القصبي، أصحاب السعادة، ضيوفنا الكرام، أيها الحفل الكريم، السلام عليكم ورحمة الله وبركاته. يطيب لنا أن نرحب بكم جميعا في هذا اليوم بمناسبة انعقاد ورشة عمل مواصفات الخرسانات الجاهزة ومتطلبات الجودة والاعتماد، والتي تنظمها الهيئة السعودية للمواصفات والمقاييس والجودة بمشاركة عدد من المتخصصين في هذا المجال من داخل المملكة وخارجها. يأتي انعقاد هذه الورشة حرصا من الهيئة على مراجعة وتحديث المواصفات السعودية وفق التطورات العلمية وبما يحقق متطلبات السوق السعودية، وتوفير معلومات لمتطلبات المواصفات القياسية المتعلقة بهذا المجال وفقا للمرجعيات المختلفة الوطنية أو الدولية. الآن حفلنا الكريم مع كلمة معالي محافظ الهيئة السعودية للمواصفات والمقاييس والجودة الدكتور سعد بن عثمان القصبي، فليتفضل معاليه.
بسم الله الرحمن الرحيم. الحمد لله رب العالمين، والصلاة والسلام على أشرف الأنبياء والمرسلين سيدنا محمد وعلى آله وصحبه أجمعين. أصحاب السعادة، الضيوف الكرام، السلام عليكم ورحمة الله وبركاته. بداية أرحب بكم جميعا في رحاب الهيئة السعودية للمواصفات والمقاييس والجودة في ورشة عمل مواصفات الخرسانة الجاهزة ومتطلبات الجودة والاعتماد، متطلعين لأن تقدم هذه الورشة مادة علمية وفنية مفيدة تلبي تطلعات جميع المشاركين وتحقق الأهداف المرجوة من عقدها. الحضور الكرام، لقد أولت الهيئة السعودية للمواصفات والمقاييس والجودة جل اهتمامها لإصدار مواصفات قياسية وطنية ملزمة للخرسانة الجاهزة ومكوناتها من الإسمنت والركام والمياه والمواد المضافة، ويتم تحديثها باستمرار لتكون مواكبة للتطورات التقنية وملبية لاحتياجات المملكة. وكما هو معروف فإن الخرسانة سلعة استراتيجية ومكون أساسي في بناء المنشآت بأنواعها المختلفة، من مباني سكنية وتجارية وجسور وأنفاق وأبراج وبنى تحتية وكثير من المنشآت المدنية والعسكرية، وتمثل خصائصها عنصراً أساسياً في سلامة المنشآت واستدامتها. وخلال العقدين الماضيين حدثت نقلة نوعية في تصنيع مواد البناء وكذلك في تشريعات البناء في المملكة العربية السعودية، ممثلة في إصدار كود البناء السعودي واعتماده، والذي احتضنته الهيئة وساهمت فيه بفعالية وفق التوجيه السامي الكريم خلال الفترة من 2002 إلى 2010 ميلادية. ولا شك أن مواصفات الخرسانة ومكوناتها تحظى باهتمام كبير من جانب المهتمين والمختصين بمجال التقييس والمواصفات وقطاع البناء من مقاولين ومهندسين. ونظراً لأن كود البناء الخرساني يعتبر جميع المواصفات القياسية المشار لها ضمن طياته كجزء لا يتجزأ منه، فقد اتخذت الهيئة قراراً ومنذ العام 2007 ميلادية بتبني كافة تلك المواصفات، والتي كانت في غالبها صادرة عن الجمعية الأمريكية للاختبارات والمواد ASTM. الإخوة الأعزاء، يتوفر لدى الهيئة اليوم منظومة من المواصفات المتعلقة بمكونات الخرسانة وطرق تصنيعها، بعض منها إلزامية والبعض الآخر اختيارية، كما أن قسماً منها يندرج ضمن المواصفات الخليجية، وبعضها قد يكون بحاجة إلى التحديث لمواكبة النقلة النوعية في تصنيع الخرسانة ومكوناتها الأساسية، والإضافات التحسينية. وستكون هذه الورشة فرصة للمقارنة وتسليط الضوء على بعض هذه المواصفات ومدى توافقها أو اختلافها عن المواصفات العالمية الحديثة، كما ستغطي الورشة بعض متطلبات الجودة وبرامج الاعتماد لمصانع إنتاج الخرسانة. إخواني الكرام، تأتي هذه الورشة ترسيخاً للمنهجية العلمية التي تتبناها الهيئة في التعاطي مع مواضيع المواصفات، حيث أن عملية اختيار المواصفات يندرج ضمن معيارين أساسيين: أحدهما الحاجة إلى مواكبة المواصفات العالمية لتشجيع النمو الاقتصادي في الاستيراد والتصدير، وثانيهما هو اشتراط ملائمة هذه المواصفات للظروف البيئية والمتطلبات الخاصة بالمملكة، كما أن توحيد المواصفات والتقليل من اختلافاتها الشكلية أو النوعية ما لم يكن مبرراً علمياً يسهم في الاستفادة من الخبرات العالمية ونقل التقنية وسرعة التحديث لمواكبة التطورات وتعزيز القدرة التنافسية للصناعة الوطنية. أكرر شكري وتقديري لحضوركم وحرصكم على المشاركة في مثل هكذا فعاليات، والله أسأل لنا جميعاً التوفيق والسداد، والسلام عليكم ورحمة الله وبركاته.
شكراً لمعالي المحافظ. ضيوفنا الكرام، للهيئة السعودية للمواصفات والمقاييس والجودة جهود حثيثة في تحديث وإقرار المواصفات القياسية الخاصة بمواد التشييد والبناء. عن هذه الورشة وأهدافها وما ستقدمه للمشاركين يحدثنا سعادة مستشار معالي محافظ الهيئة للمواصفات الأستاذ الدكتور أحمد الشريم، فليتفضل سعادته.
السلام عليكم ورحمة الله وبركاته. صاحب المعالي، أصحاب السعادة، الأخوة الكرام، السلام عليكم ونرحب بكم أجمل ترحيب في هذه الورشة. ضمن البرنامج العلمي للهيئة السعودية للمواصفات والمقاييس والجودة تقام ورشة عمل مواصفات الخرسانة الجاهزة ومتطلبات الجودة والاعتماد. حقيقة السؤال اللي يمكن يطرح نفسه إنه لماذا هذه الورشة؟ ما هو الهدف أن نقيم هذه الورشة؟ فلتسليط الضوء على هذا الموضوع في 3 أبعاد تعطي الأسباب والتوضيح لماذا. البعد الأول هو استراتيجية الهيئة، وسنسلط الضوء على بعض النقاط لتوضح هذا الموضوع. فبالنظر إلى بعض المكونات الاستراتيجية متمثلة في الرؤية والرسالة، حيث تفيد الرؤية بأن رؤية الهيئة هي تحقيق الريادة الإقليمية والمرجعية العلمية في مجالات تقييس وتقييم المطابقة. فنحن هنا نتحدث عن المرجعية العلمية اللي هو التوجه الهيئة في استراتيجيتها ال5 سنوات القادمة، ابتدأت من العام الماضي يعني إلى 2018، وبالتالي فيها التركيز على القضايا العلمية. عندما ننظر إلى الرسالة، الارتقاء بمواصفات وبجودة المنتجات والخدمات لتعزيز حماية المستهلك والتنافسية للاقتصاد الوطني. إذن هنا نتحدث إلى بعد حماية المستهلك، وهذا هو أحد الجوانب الأساسية في موضوع اللي تهتم فيه الهيئة وتعكسها في رسالتها. عندما ننظر إلى الأهداف الاستراتيجية سنجد أنه في بدايتها تعزيز سلامة المستهلك، رفع مستوى رضا المستفيدين، ترسيخ الثقة بالمواصفات الصادرة عن الهيئة محلياً وإقليمياً، تعزيز ثقافة الجودة في المملكة، تعزيز الدور الرقابي للهيئة وتأكيد مرجعيتها العلمية. إذن هنا نتحدث عن منهجية الهيئة وتوجهاتها الأساسية، فقط اختصرت لكم هذه الجزئية من استراتيجية الهيئة. البعد الآخر أو البعد الثاني هو يتعلق بالخرسانة ذاتها. يعني بمعنى آخر، لماذا اخترنا الخرسانة؟ نعم، من حيث المبدأ لماذا نعمل ورش علمية، ولكن السؤال لماذا الخرسانة؟ الخرسانة مثل ما أشار معالي المحافظ هي سلعة استراتيجية، وكما نلاحظ فهي، وتعرفون طبعا لستوا يعني أنتم جميعا ما شاء الله خبراء، الخرسانة هنا دورها الأساسي في بناء المباني السكنية والتجارية والجسور والأنفاق والمنشآت والمستودعات الاستراتيجية للتحلية والوقود وغيرها. ولذلك هي يعني في غاية الأهمية، وسلامة هذه المنشآت مرتبط بشكل كبير سلامة هذه المنشآت مرتبط بشكل كبير بجودة الخرسانة. على الجانب الآخر زي ما بنلاحظ إنه الخرسانة تتكون من المركبات المعروفة من الإسمنت والركام والماء والميكستشر أو المواد المضافة والمواد البديلة المعدنية والبوزلانز. وهذه المواد بالتأكيد أنها تنتج عن مصادر أو تستخرج من مصادر طبيعية وصناعية. ففي هذه ما بين هذين الجانبين يقوم المواصفات القياسية وكود البناء وبقية التشريعات الوطنية بضبط عملية الجودة والتحكم فيها. فهنا نلاحظ الصورة الكاملة. الجانب الآخر في الموضوع ذا، موضوع الخرسانة، إن الخرسانة تتأثر بظروف طبيعية وتتأثر في مجموعة ظروف وتأثر فيها أيضا. فهي تتأثر بالظروف البيئية كالحرارة والرطوبة وأملاح التربة، كما أنها تتأثر بالأحمال التي تتعرض لها. إذن هنا الجانب اللي تتأثر فيه الخرسانة. وفي الجانب الآخر الخرسانة ذاتها طبعا تنتج مواد طبيعية من موارد طبيعية ناضبة في بعضها، ولها تأثيرات طبعا فيها الطاقة، مصروفات الطاقة، ولها والموارد المالية، ولها التأثيرات البيئية. فما بين التوازن تأثيرها على الموارد والبيئة وما بين تأثرها، لابد من الاهتمام بالاستدامة والمواضيع المتعلقة بها كالديمومة وخرسانة الأجواء الحارة والتكامل ما بين الكود والمواصفات لتحسين أداء المنشآت وإطالة أعمارها. فهذا هو المخرج ما بين ما تتأثر به وما تؤثر فيه. البعد الثالث في أسباب قيام هذه الورشة هي المواصفات نفسها. يوجد لدى الهيئة منظومة مواصفات، سنرى بعض الأمثلة منها. فيما يختص بالإسمنت، لاحظ أن لدينا 9 مواصفات، ما بين المواصفة الخليجية إلى مواصفات خاصة بالهيئة السعودية الساسو، إلى مواصفات متبناة من الSTM، إلى مواصفات متبناة من خليجية متبناة من الأوروبيان. فهذا الخليط حقيقة بعضه يحتاج إلى مراجعة، يحتاج إلى نظرة أخرى. لماذا لدينا هذا الكم؟ هل فيه شيء يحتاج إلى تحديث أو شيء يحتاج إلى توحيد؟ فهذه أحد النقاط في هذا المجال. في المواصفات المتعلقة بالخرسانة الجاهزة، تصنيع الخرسانة، أيضا لدينا مزيج من المواصفات المصادر المختلفة من الآيزو ومن الإي إن والمواصفات الخليجية ومواصفات الASTM. فإذا لدينا مجموعة تحتاج إلى مراجعة وتحديث. لماذا التحديث؟ طبعا التحديث أسبابه ممكن تلخيصها في مواكبة النقل النوعية في تصنيع المواد وتحديثات الكود السعودي والخليجي اللي هو الآن أيضا تحت العمل فيه، بالإضافة إلى أن توحيد المواصفات والتقليل من اختلافها يساهم في الاستفادة من الخبرات العالمية وسرعة التحديث وتشجيع الصناعة الوطنية. إذن فيه إيجابيات للتحديث. السؤال الآخر حقيقة هو لماذا ASTM؟ لماذا الاهتمام وإقامة هذه الورشة مع ASTM؟ هناك أيضا جملة أسباب. ASTM طبعا هي المواصفات المعتمدة ضمن الكود السعودي، هي المواصفات المتبعة أكاديميا في معظم الجامعات السعودية إذا لم تكن الجامعات العربية، هي المواصفات المرتبطة بمعهد الخرسانة الأمريكي ACI المعروف والذي يمثل مرجعية فيما يخص الخرسانة. السبب الأخير أن هناك ضرورة للتعديل طبعا، وهناك إمكانية التعديل، يعني استخدام ASTM يسمح بأنه تجري عليه التعديلات اللازمة لمناسبة الظروف البيئية والمتطلبات التشريعية الخاصة بالمملكة أو حيث بأي بلد، لكن حديثنا الآن عن المملكة. كما تلاحظون محاور الورشة هي حيث تغطي هذه الجوانب اللي احنا تكلمنا عليها، فحتكون حديث عن المواصفات القياسية بصفة عامة، حيكون في حديث عن المواصفات إنتاج الخرسانة الجاهزة ومكوناتها، وهذه الموضوعين حنتكلم عليهم اليوم. حيكون فيه مبادرات عن الاستدامة وفكرة الاستدامة اللي هي أحد القضايا الأساسية، ومراقبة البيئة. حيكون في حديث عن الخرسانة وعلاقتها بكود البناء واعتبارات الديمومة، كما سيكون في حديث عن اختبارات الخرسانة للتحقق من الجودة وخرسانة الأجواء الحارة، وكذلك عملية إجراء اعتماد المصانع وإصدار الشهادات. هذه حتكون من التجربة الأمريكية في هذا الموضوع، وكما أن هناك تجربة محلية في مراقبة مصانع الخرسانة الجاهزة. سأتحدث عن المحاضرين بشكل مختصر حقيقة اللي قدموا محاضرة اليوم، وأطلب من كل منهم يعني في وقته يمكن يضيف، لأنه ما في مجال نتكلم بشكل كثير. المحاضر الأول هو الدكتور ريتشارد سيتشي. دكتور سيتشي دكتوراه في الهندسة المدنية ومهندس محترف، عمل في عدة مناصب، خبير تقني ورئيس قسم بجامعة، يعمل الآن رئيس شركة للخرسانة الجاهزة في تكساس، وعمل في عدة لجان فنية من ضمنها طبعا ASTM ACI ASCE تبع الهندسة المدنية، واللجنة الأخيرة اللي هي خاصة باعتماد مصانع الخرسانة NRMCA. المحاضر الثاني الأستاذ الدكتور عبد العزيز النغيمش، أستاذ الهندسة المدنية للإنشاءات في جامعة الملك سعود، ومدير مركز التميز لأبحاث واختبارات الخرسانة. لديه عدة أبحاث وحصل على جوائز متعددة وبراءات اختراع، وعمل في مراقبة مشاريع الجودة للأمانة الرياض وكذلك لجامعة الملك سعود. بالمثل الأستاذ الدكتور عبد الرحمن الحزيمي أستاذ في جامعة الملك سعود، ويعمل في مركز تميز لأبحاث واختبارات الخرسانة. لديه مجموعة من الأبحاث وحصل على براءات اختراع وعدد من الميداليات الذهبية. خبراته العملية في مراقبة الجودة وأيضا لأمانة الرياض ولجامعة الملك سعود. لدينا 3 مشاركين من القطاع الخاص: السيد رضوان حميد من شركة ريدي ميكس سعودي ريدي ميكس كونكريت كومباني، ولدينا السيد كريستوفر ستانلي من شركة يونيبيتون ريدي ميكس، والسيد رامي شطارات من شركة ترانس جلف ريدي ميكس كونكريت. فسيتحدث كل منهم في وقته يوم غد وبعد غد لمدة 20 دقيقة تقريبا في أوقات محددة لهم مسبقا. نشكركم جميعا، وأعتقد أنه أستطيع أقول في هذه المناسبة أنكم أصدقاء الخرسانة مثل ما أنا كذلك، وأصدقاء البيئة، أصدقاء المواصفات، أصدقاء الكود، فعلينا أن نهتم بأصدقائنا جميعا ونوازن بينهم. شكرا لكم والسلام عليكم ورحمة الله وبركاته.
المواصفات القياسية الخاصة بالخرسانة متنوعة بشكل كبير. يقدم لنا الدكتور ريتشارد شيسكي مقدمة عن تلك المواصفات وطرق الاختبار والتأثير الصناعي لها، فليتفضل سعادته. نود أن نلفت انتباهكم إلى أنه يوجد أجهزة ترجمة عند مدخل القاعة لمن يرغب، لأن المحاضرة ستكون باللغة الإنجليزية.
Assalamu alaikum. I've been practicing that for a while. I hope it worked. Good morning, and thank you very much to Sasso for inviting me in. Thank you very much for having me come all the way over here. I've said several times I enjoy coming to the Middle East. This is my first time to Saudi Arabia, and it has been nothing but wonderful since I've been here. So thank you very much for having me come in. I'm going to be here for several days, going through several presentations. I will try to speak a little bit slower than I normally do for the translation. But today, my first presentation will be on ASTM. You heard several times, some of you may be familiar with ASTM. You heard several references to the ASTM standards. And I thought in my first presentation it would be important to cover what ASTM is in our process. I've been dealing and working with ASTM for 2 decades, 20 years writing codes and standards for ASTM. Sometimes the overview may help a little bit in how we develop the documents. So I'll talk about that and think that may take for a long time to do. That may take years upon years upon years to develop a single standard. With the process I'm going to show you, we can rapidly change a standard to represent the newest technology that is being used or has the potential to be used. That process is so important for developing the standard. I will mention here about the largest voluntary standards development organization in the world. You saw the numbers there, the number of people that are participating there. As was mentioned, it is voluntary. ASTM is not a mandatory standard anywhere unless a government adopts it. A government has to adopt it for it to become mandatory in that locality, in that location. ASTM has no, in the United States, it has no governance unless someone adopts it. So that's the key part. Somebody has to adopt it into a building code, into a local code, a national code. The only place that ASTM, everybody says, well, how does ASTM fund itself? Where does the money come from? The money from ASTM, the funding, comes from the sales of those documents, the standards. That's it. There's no government money that goes into it. It functions as a business. So if the standards aren't relevant, no one's buying them. So the standard has to be relevant in a rapid pace for the industry to want to purchase it so it can be used. So there's a little bit of a relationship there between the industry, its use, the money, and its adoption. Now, here's the other part about this. I mentioned this word consensus. Every member has an equal say. Now, by example, let's, you saw up there a couple of ready-mix companies. So I'm a ready-mix company, a national ready-mix company. I have 1,000 employees. Sasso has 1,000 employees. A cement company has 1,000 employees. Can they all be members of ASTM? All 1,000 members can. They can receive, they can participate, but when it comes to votes, one company, one vote. So while I may have 1,000 employees, I get one vote, the company does. Sasso gets one vote with its 1,000 people. Somebody has to carry the one vote there and represent all of that consensus from that group at ASTM. So everybody gets equal say, every member does, but when it comes to voting, we don't like to overwhelm the voting with everybody from one company. One company, one vote. Now, but do I have to be a company? I'm just a single consulting engineer. I don't work for any other company but myself. You are the company, you get one vote. And I'll show you how that goes here in a little bit. Now, the other thing is that we have these things, you're going to see this term committees. You're going to see the term committees a lot when it comes to ASTM because that's how we're organized. But you'll notice who's on those committees. We've got members of the product manufacturers. We have regulatory agencies. We've got the end users, the consumers. We have professional societies. Sasso would be a professional society. We've got academics, professors working at universities. So we have this collection, what we like to think of the greatest minds in concrete, all in one place at one time, giving input, producing a document that's relevant that everyone can use. So here's examples of some committees. Now, take a look up there and look at how broad some of those are. You've got stainless steel, you've got plastics, petroleum products, sport aircraft. Those are all the groups that ASTM works on. So very, very broad, very, very wide. But I showcase for you an example up there, C09, concrete and aggregates. That's who I've been working with for 20 years, is C09. That is my committee that I've been working with, and arguably everybody here in the room would also be members of, participating in C09. Now, how are the standards used? We developed the documents. How are the standards ultimately used? Well, voluntary consensus there. And here's where it gets interesting. Cited in contract documents. Any of you that have been in construction, any of you that have built something or participated in building something, know how important the contract documents are. The piece of paper. That's where these things start to get listed. That's where the documents start to show up. in my case, sometimes we've had issues on job sites. Sometimes we've had issues in construction. And no matter how many friends I have that are working there, it always comes back to the documents. What does it say in print? What does it say in the documents? And when it says an ASTM standard listed there, that's what we wind up saying, where we wind up going. Well, that's not what we do in the field. We do something different. What does it say in the document? That's why it's important to list them there, and that's why they show up in contract documents. The other thing is, we also have them listed from a national law and international law standpoint. Why is that so important? Is that because some of you, myself included, have been asked to participate in projects that are in other countries. And all of a sudden, we're now crossing borders with technology, with viewpoints about what concrete can and cannot do, testing methods. Just because I'm building a project in the United States doesn't mean that there's not an engineer in Saudi Arabia that isn't consulting on it. Just because I'm producing cement in the United States doesn't mean that cement won't be used somewhere else in the world. I use cements in the United States from around the world. So we have to have some kind of uniform standard in which to evaluate, measure, and use those products. That's why the other reason why we have these uniform standards. So, now, technical committees. Now, I want to start to narrow down a little bit into the committee system because this is where the work gets done. This is where we begin to argue over language and why words are important. The difference between you shall do something and you may do something. One is mandatory, one is non-mandatory. Though just arguing over those two words, shall and may, is so important for what happens in the field. So, each committee had something as a staff manager. That's a professional person that works for ASTM. They kind of make sure we're all working together and kind of moving the process forward. They handle the paperwork for us. They handle the documentation. And the other thing that is critically important is they make sure communication is happening. They make sure that people are continuing to talk to each other to make sure this happens. Now, there's a whole, I know that SASO does something very similar to this with using web balloting, electronic communications, all of that means things move faster. Now, I've been doing this so long with ASTM, I remember when we used to do things with regular mail and we would send packets of paper out. And it would take weeks to get out and for people to fill them out and for them to return them. Weeks upon weeks, which would delay the project, which would delay the document, not just by months, but years. Now, through the internet, things happen rapidly, quickly. And we get response back, and all of a sudden we can make not only the documents relevant, but they can happen very, very quickly so that people in the field can use them and can be downloaded. And the engineering community, the construction community gets the latest, most technologically advanced document. Now, this one here is how we set up the structure. So, the main committee, CO9, concrete and aggregates. Underneath each one of those is a subcommittee, CO920, aggregates. CO940, ready mix concrete. And beneath that, we go into what are called task groups to talk about things. Now, CO940, I just finished 6 years as the chairman for this group right here. Now, underneath that, that's where there's a bunch of documents that are relative to just that category. In January, I take over as the chairman of this group here, of aggregates. And all we're going to do is deal with aggregates and aggregate technologies and changes there. The world of concrete, we may think it's relatively simple. It's aggregates, it's water, it's cement. It's very just three basic products. When it comes to talking about them, we have to break them into very small groups because there's a lot of people that have a lot of information about how to change those documents. The focus here is to make sure that we have the most accurate and technologically advanced information from all of the groups: academics, user groups, engineers, specifiers, producers. And then finally, these task groups is where we actually write the standards. So what happens is the document draft, you'll hear this term too, draft language. Somebody proposes something, and then we get to talk about it in a task group. If we agree in the task group, then we push it up here to ready-mix concrete. If that group agrees on it, it gets pushed to here, and if that group agrees on it, it becomes a standard. Now you may think, as you're looking at that takes a long time. It doesn't. It can happen very, very quickly. And as part of that process, anybody can raise their hand and say, I disagree, and then we have to address their disagreement. I'll talk about that here in a little bit. So, as I talked about, this is kind of how it works here. The task group to the subcommittee to the main committee, and then we have a group that sits on top of that. I'm actually a member of this group as well. This is the group that makes sure the process is done correctly and that everybody's opinion has been heard. It's kind of like a police force that sits on top that makes sure the process has been done correctly. That's a key part because remember, consensus and everybody gets a vote. If somebody says, my vote wasn't heard, what is their recourse? What do they get to do if somebody says, I haven't been heard? That's where this group comes in. Now, very rarely do we ever have to get involved, but sometimes we do. Somebody says, my vote wasn't considered. Or when I raised my hand and said, I disagree, that's also something called a negative. My negative was not addressed. That's where this group comes in. Now, the other thing that we are very, very focused on within ASTM is something called balance. Balance. Now, let's say, for example, I take this room and I say, everybody on this side of the room work for the producers. Everybody on this side of the room produce concrete. And everybody from here over are the users of concrete. And I want to take a vote in the room. And I say, how many people in here think that this part of the concrete is important? All of the producers raise their hands. All of the engineers over here say, no, we disagree with that. Well, I count up the votes, and guess what? The producers win. That's out of balance. That's out of balance. That's not an equal representation. And what could happen is, all of a sudden, the standard gets written so it favors concrete producers, but doesn't protect the users. So we have to maintain this balance here between the producers and the users in general interest. And the way we decide that is, producers are very easy to determine. Do you make concrete? Users in general interest? Everybody who's not a producer. It's very, very simple. And we balance those and make sure that every committee has a balance of that. That way no one can say that the document is biased. So this balance is critically important. I talked about this here, only one vote assigned per company and how important that is. Again, that's part of the balance to manage that. Now, every member receives a ballot. This is the other thing. Every member gets an opportunity to vote, but not every member votes. Every member gets an opportunity to vote, but you're not required to return a ballot. So, let's go back to my example again. So now I take the room and now I have equal balance. I have equal balance. But if I get 100% return rate on the ballots here, but I only get 50% return rate on the ballots here, am I balanced? The results are not balanced, but everybody but the opportunity to create balance existed. Do you understand the difference, how important that is? Just because the return ballots are out of balance doesn't mean that the balance in the committee was not there. Everybody had an equal opportunity to participate, but some chose not to. That's another part about this, is everybody gets an opportunity to say something. We always like to have a phrase, non-response constitutes acceptance. Non-response constitutes acceptance. You had an opportunity to respond, but you chose not to. I was too busy today. Or I didn't have time. Oh, okay. Well, the vote still goes on. The process still moves forward. So just because you didn't respond doesn't mean the process stops. So this is the other part. We always have to tell people, you have an opportunity to participate. You get to choose whether you take advantage of that opportunity. Okay. Some basic documents. Now, we break ASTM documents down into 3 documents plus 1. So the 3 documents are, the first is standard specifications. Those are explicit requirements for a material, product, system, or service. That's a standard specification. ASTM C94, standard specification for ready-mix concrete. Standard specifications. The other one are test methods, standard test methods. That's a procedure to perform a test. ASTM C143, standard test method for performing the slump of ready-mix concrete. It's a test method. So there's a distinction there. Standard specification, test method. There's also a standard practice, which is the third one. These are a little bit, we don't have as many of these standard practices because these denote operational aspects. And then finally, I'm going to talk about this, I think on the last day, are these PCRs and EPDs. Product category rules and environmental product declarations. These have become critically important for us in the aspect of sustainability and green building. Some of you may have experience with those, but right now, PCRs and EPDs are extremely important. They're one of the number one things we are talking about and developing and adopting when it comes to concrete construction right now. But I'll talk about those in I think on day 3. So we're going to focus a lot of my discussion is going to be on standard specifications and test methods because that's the key part about adopting the standards. So we use standards as a broad term to address both standard specifications and test methods. Now here's some examples of standard specifications. ASTM C33, standard specification for concrete aggregates. C94, a standard specification for ready-mix concrete. I highlight this next one specifically because this is very important. ASTM C125, standard terminology relating to concrete and aggregates. That is so important because that's definitions. Language matters. Remember how I was talking about shall versus may? The language matters, which means we have a group. This is probably of the committees within ASTM, this is probably one of the most powerful committees that we have. One of the most influential committees is the one that determines the definitions. Because when we write the documents, we use terms from all over the place, but C125 is the ultimate place where they are defined. The definition committee is one of the most powerful committees within ASTM. Then 1157 and 1602. Now, I also want to highlight for you something on this list. Notice the numbers. 33 down to 1600. In our document, in ASTM system, the smaller the number, the older the standard. The smaller the number, the older the standard. The bigger the number, the newer the standard. So of this list, the newest standard is 1602 on water. So when you're looking at ASTM documents and you're referencing them, you can tell the most modern one by its number. Now, I'm also going to show you one more thing, too, in the standards when we get to them about how often they're updated. There's a way that you can know if it's updated as well. Now, I'm going to give you a quick example of something that we wanted changed. We've been working on this for 18 months. This is an example out of ASTM C33. I personally, this is my personal idea that I had for changing this document. And so what I said was, I wanted, if you'll notice right here, this is the existing language in white. In the case of manufactured or recycled sand, I wanted the term recycled added into the document because we were producing sand that was recycled. We had a waste material that we actually could say is a recycled product. We weren't disposing of it. We could put it back in the use of concrete. So we were recycling it. But the standard did not define recycled. So I had to come up with a definition of this and put it into the document. This yellow represents changed language in ASTM C33. So I was a member, and I got to say, I would like to change the document. And here are my changes. So I submitted that to the committee, which gave it to the subcommittee, which gave it to the task group. And I said, and then I had to go forward in front of that task group, and I had to stand up, and I had to say, I would like to see these changes, and here's why. We're a technically based, scientifically based organization. I had to stand up and I had to say, here's why, and I had to present data, and I had to present information as to why this was an important change. It also affected a change in another part of the document. Fine aggregate shall consist, notice the word shall, consist of a natural sand, manufactured sand, or a combination thereof. I said, I want recycled sand as part of that. Somebody in here may say, oh, I want sea sand as part of that, if you worked on the Gulf Coast. Coarse aggregate shall consist of gravel, crushed stone, air-cooled, blast furnace slag, including crushed hydraulic cement concrete. I wanted the term recycled aggregate put in there as well. This was all one change I was making. So I got to stand up and say, this is what the change I want, and here's why I want this change. And then people got to ask questions, and I got to respond. And then this went to what is called a ballot. I said, here are the changes. Here's my rationale. That's another key word. My reason, but we use the word rationale for making the change. The ballot goes out to all the voting members. We tally the results, and a consensus, 51% said, yes, this is an appropriate change. But at any point in time, somebody could say, I disagree. I vote negative. And here is why I vote negative. And then that person gets to stand up and say, I disagree, and here is why. And then I stand over here, and I say, well, you should change your opinion. And this person says, well, my opinion is important. I'm not changing my opinion. So then what we do is we say, okay, we then as a group vote as to whether or not this person, their opinion is more valid than mine. And we take a vote. And the group finds this person two key words: persuasive, meaning they agree with him, or non-persuasive, meaning they disagree with him and they think I am correct. If people find him persuasive, I have to start over and find out how to incorporate that comment If they find that I'm persuasive, or not, they find I'm more persuasive than him, then the ballot goes forward. So I always like to say that if you are afraid of standing up and expressing your opinion, ASTM is a difficult place to be. You have to be able to stand up and argue for your point, the scientific, the technical merits of it. To me, that's one of the great parts about this. During the opening presentation, it was mentioned about our love of concrete. That's why we're here, to produce it, to make it, to use it, to impact our community. I like arguing about concrete. ASTM likes arguing about concrete because ultimately that discussion, that argument, makes it better, makes it safer, makes it more technologically advanced. And that is part of our process here when we do this. So, we're a little bit ahead of schedule. Does anybody do we have time for questions? Is there any initial questions that I can answer about the process? I'd be more than happy to do that, and I can always go ahead and start my next presentation as well until we go to the coffee break, if that's okay. Are there any questions? Can I take questions? Is that okay? Oh, please. Yes.
But they found sometime in ACI 555 cycle, they found that cycle sand sometimes recycled aggregate would have more absorption for water and sometimes affect the results.
Yeah. His question was, in this particular case example that I gave here, the use of the recycled aggregates, that there are other committees, ACI, that found that the use of some of these products can cause problems from an absorption standpoint in concrete. He's absolutely correct. One of the things that we try to do when we write the standards is not restrict or prohibit the business community, the producers, from coming up with the best product. Doesn't mean that the product is unsafe. But we want to make sure that if somebody has a good idea on the use of recycled aggregate, his point about absorption, it's a very, very key point. The use of some of these products can result in a higher absorption rate. And someone who doesn't know that, if they read the standard and says, oh, we'll just use this, a mistake can happen. Well, there's several checks and balances along that process that will show in the results. But what happens if I'm a company that knows how to do it, and still produces a high-quality product that's safe for the user? I should not be restricted by my choices because someone else does not know how to do it correctly. So when we write the standards, when we make these changes, that's the key part of that argument, that discussion that goes on, is how do we balance both ends of the spectrum? The lowest common denominator is oftentimes how standards are written. And sometimes when you write a standard to the lowest common denominator, you prevent people that have a different approach to technology from participating, meaning that if you continue to have a low common denominator, you can't raise the quality at all. Well, what about this guy? He doesn't have this, or they don't have access to this, or they don't have the ability to understand. Well, what about all these people over here that they do have the ability to produce a quality product? They do have better technology. They do have a better investment. They do have better people. So that's the part of the standard, and this is, you highlight a key aspect of this because that was probably one of the number one points being argued as to why not to make this change. Well, what about all these problems that could occur? Well, those problems could occur right now today with the regular aggregate. When we add in this other one, we have all these other problems, but what about the people who know how to deal with them? Why should they be limited? So in writing the standards, that's a key part, is making sure we don't restrict people's ability to find the best possible answer. Because my experience from a field standpoint, from an industry standpoint, is as businesses, we are always going to seek the best, most economical answer. We will find a solution to that as businesses. We have to make sure that the standards are written in such a way that it allows that, but still protects the user. That's that balance. Yes, sir.
I wanted just to ask about the withdrawn standards.
Withdrawn standards.
There is some standards, they have no replacement, and other they have replacement. So in my search, for example, standard D1994, the ASTM standard, they make withdrawn at 2003.
Yes.
But it's still some of laboratories, and they make this test at with this standard. So when I go into search about the replacement, I cannot find. But we still did it, yani.
Yeah.
I want just to ask why they withdraw no replacement, and for example, what is the method to search about the replacement? Thank you.
Okay. So his question was about a withdrawn standard. So I'll go back to this here. Standard specifications, standard test methods. These would be examples. So in this particular case, he asked about a standard that's been withdrawn. I mentioned something earlier about making sure that the standards were relevant and up to date. There is a requirement in ASTM, within ASTM, that every standard, every specification, every document must be updated within every 6 years. Something has to change in that document within a 6-year period. And what that means is somebody is coming back and looking at it going, is there any change in the technology? Has something changed? Now, some standards are being changed every 6 months. Something is happening. Some standards, there's not that much happening to them. But every 6 months, every 6 years, they have to be reviewed for update. Now, in this particular case, there could be a document that it hasn't been looked at in 6 years. And in 10 years, if nothing has been updated on it, it can actually be what's called balloted for removal as a standard, meaning nobody's using it anymore. And we start asking, is anybody using the standard? Is anybody using the standard? When we ask everybody, is anybody using the standard? Non-response constitutes acceptance. So if we heard back that nobody was using the standard, it gets pulled out of ASTM. Now, it doesn't mean it's no longer in use. It's just not in the book anymore, and it sits over here on the shelf. And there was somebody somewhere that's been using it that we never heard from, that was not a part of ASTM, that was using it as part of their documents, in your particular example. Now, let's say that you're still using a standard that's been removed. There's nothing that says you can't come back and say, I'm a member of ASTM, I need this document to become relevant again. Well, as soon as you raise your hand, what's going to happen is you're going to wind up being the chairman of the committee, and you're going to be asked to revive it. That's the other thing at ASTM. If you raise your hand saying, I have a question or I have a good idea, chances are we're going to put you in charge of something. So you always have to be careful about that. No. Now, is there anything that says you cannot use it right now? You absolutely can reference that as a standard and use that. There's nothing that says you can't. It's just a removed document. You have to pull it out of the archive, and you could use it. But if you'd like to change it, because you've got a new way of doing something, the technology may have changed, there's nothing you can do about that because it's been removed as a standard. That's the downside for using a removed standard. Does that answer your question a little bit? Okay. Question in the back. Yes, sir.
Good morning, Mr. Richard. You hear me?
Yes, I can hear you.
Good morning,
Good morning.
Richard. Maybe my question a little bit strange.
We're talking about ASTM.
Strange.
There's no strange
listen.
questions.
I want frankly your answer. Do you think ASTM covers everything in our life?
I think
I mean, now this ASTM 18,000 or something in public, are there any ASTM not shown to everybody? Strange. Okay, I will give you some example. Nuclear,
Okay.
number one. Number two, blast-proof technology. Understand my question? Thank you. I need your frank answer, please. Thank you, sir.
I don't understand your second. Let me address your first question for the
Yes.
first one. So his question was, if I understand it correctly, was ASTM being shown to everyone? Is it available to everyone? Is it accessible to everyone? Right now, today, you can go to the ASTM website, www.astm.org.org. You can look up a standard, you can search it, and you can download it right now. It downloads as a PDF file. Anybody can access that anywhere in the world.
But sometimes you must pay. Sometimes, if you ask for that, you must pay some dollars.
Sometimes, yes.
Yes.
Yes, you have to pay because remember what I talked about, that how the organization runs. Now, here is where it gets interesting. So now, let's say that I want to do a project for the federal government in the United States. I'm going to build a federal building. And the federal government references as a standard ASTM on how to do concrete. Well, the federal government, its standards are open. It can't charge someone to buy its standard. But it references a standard that you have to pay for. Now, you have the same problem when it comes to ACI, ACI International. They're a code. And in the United States, it's codified, which means it's part of law. It's the building code. Well, that's a for-pay standard as well. So that's the problem that we've got is they're accessible to everybody, but they're for pay, and you have to purchase it. We haven't figured out a way around that yet because that's how the two organizations, that's how ASTM is funded, is through the sale of its documents. Now, other organizations may make them publicly available. I'm not sure how to answer that any other way than it. It's available to everybody, but yes, you have to pay.
ASTM are hidden.
Are hidden?
Not to public, not to everybody. Like I told you, nuclear.
Oh, the nuclear ones.
Yes.
Oh,
yes.
yes. Now, nuclear can be because of safety reasons and making sure that you're qualified to purchase those. We have the same issue in the United States with federal bridge standards and nuclear regulatory standards. I've been participated in a nuclear construction project. Very, very difficult. You had to get a lot of certifications just to even see the documents. I don't disagree with you there, sir. That is very difficult. You had a second question.
Anti-blasting. Now we have here to design, for example, some buildings, blast-proof buildings. Blast. If some explosion happen, for example, like power plants,
Yes.
PP. The blast-proof technology is not very clear in your ASTM.
No.
How can I design a building to blast-proof, let's say 1,000 TNT? How? I don't know.
Okay, so his question was about blast-proof standard. Now, great question. I'm gonna give it highlight that as a very specific example. So let's say the blasting community, the people who design that, it's a very small community. And let's say there's 6 contractors or 6 producers in the whole country that do that. Their subcommittee, I'm going to back up here to a slide. This group right here, this is how it breaks down. So let's say that I have a C0941 over here, blast-proof. Well, that's what we'll call it, that develops the standard. In C0940 ready-mix concrete, I have 300 members of that committee. 300 members of that committee. Producers, testing labs, users, engineers, specifiers, all part of that group. But in the blasting one that sits over here, this group, there's 6. There's 6 people that are there. They show up to the meetings. 6 people that are part of the balloting process. Remember what I told you about the balloting process? 6 ballots go out. What do I need for consensus? 4. 4 people decide the standard because it's such a small group. That's the downside of very, very specialty types of groups, is that the standard can be controlled by 4 people that they're the only people that are interested. So, that group may be the only ones that are interested in developing that standard, updating the standard. That's the downside to it, is that I have 300 people here that are using that every day, all day. They may be having, there may be changes that they know about. But in this one over here, this other small group, there's 6 people, 6 companies, and that's it. So that's the other aspect about the standards, particularly specialty ones, about making sure that they're relevant, updated, and those kind of things. Any other questions? And the other thing is, if I don't answer some of your questions completely here, I'm here for 3 days, and I'll be available at all the breaks as well. We'll have time for a couple more questions till we go to break. Yes, sir. Okay, thank you. Yes.
Hello, Dr. Richard. My question is actually about translating the standard to another languages. You know, not all the standards is equal. Some of them, as you said, C94 are universally or internationally used. And if we say that we won't translate this standard to another language, what's the ASTM procedure for it? This is the first question. The second question is, who's actually do the translation?
Okay. So his question was about the translation of the standard into another language. So one of the things that ASTM has started doing in the last 5 years is converting standards to what's called a dual standard. So it has both metric and SI units. So the units can be used internationally. So that's one thing that was done. The other thing was with the translation of the document itself into another language. Those translators are at ASTM, their headquarters in Pennsylvania. Now, I can tell you from a person who's been there and seen that, they need all the help they can get, making sure that they're using the correct language. The subtleties in translation are very, very important. Much like you're listening to me now, some of you are, there are probably small words that aren't translated precisely from English to Arabic. And that's okay, I understand that, but it takes a couple of people to sit in a room and say, this is how you should write this sentence, versus this is the way it is written. There's plenty of people there to listen. I don't know that they have 100% of the expertise for all the languages around the globe that are using them. Now, if you have a specific issue, that's a great thing to, as a member, to say, this did not translate correctly, we need help. That I know they rapidly respond to, because you're not advocating for a technical change. You're advocating for a language change. That's completely different. Make sense? Okay. We'll have one more question, then we'll go to break. Yes, sir.
My question that in the website, when we search about by word, not by the standard number, so we find sometimes different numbers with documents and something else.
Yes.
So what is that, and what is the related between this?
So his question was, you want to do a search on the website and you type in concrete. ASTM C94 comes up, but so do a whole bunch of other documents. Some of them are for standard specifications, some are standard test methods, but then there are some other ones there about studies, research studies, something called an ILS, interlaboratory study. That's where somebody says, I want to make a change to a test method, say the slump test. somebody had to do the data and the research to support the change. And so what they'll send it out is to, well, we want this laboratory, this laboratory, this laboratory, and this laboratory to run the tests. Develop the data, let's look at the standard deviation and see if the change had an impact. And ILS is an interlaboratory study that is where the research was done to support the change. Make sense? So that's one of the other documents that come up. It's right at about 10:20. This is our time for the break. So I'm going to end here. Thank you very much for the first presentation. I'll continue to be around, and I'll turn it back over here. Thank you.
Thank you very much, Mr. Richard. ورقة العمل القادمة ستكون عن مواصفات مكونات الخرسانة، الإسمنت والركام والإضافات الكيميائية والبدائل المعدنية، ويقدمها الدكتور كذلك ريتشارد شيسكي. الآن سنتوقف لمدة 20 دقيقة للاستراحة، ويوجد مرطبات في الخارج في الجهتين، في الجهة القريبة من باب القاعة وفي الجهة المقابلة الغربية، لكي نتوزع أساس ما يكون في زحمة على الأماكن الإفطار. شكرا جزيلا، ونراكم بعد 20 دقيقة إن شاء الله في 10:40 دقيقة.
Oh.
بطريقة عادية.
Dr. Richard.
Whatever I can do to help.
ليش؟
ما البني ادم يرفع ابدا، ما كنت بلحقها الرجال مع الرئيس تليفونكم ما حد يرد عليه، والله ما حد يرد، والله ما حد يرد من يوم الاثنين الاحد الاثنين الثلاثاء، من يوم الاسبوع الاحد ما في، الاثنين ما في، السبت ما في، ما حد يرد، ولا الاحد ولا الاثنين ولا الثلاثاء ولا لين ما جينا. ما يصير هذا المواصفات يرد ينفع، بس خلاص خليه مسؤول زائد المواصفات الكويس بعدين ما يكلم، ما حد يكلم. تحبون دليل تبغى القسم الثاني، تبغى القسم الثاني راح اشوف بس مجرد يقول لك ان هذه المواصفات دلوقتي يقول هذه حفظتها 45 20,000 حفظت رد عليك احد؟ ما يرد، والله ما يرد، ولا تقعد لين بكره لما تدي لك خلاص هذه المواصفات خطوه
السلام عليكم. نرحب بكم مرة أخرى في ورشة عمل مواصفات الخرسانة الجاهزة ومتطلبات الجودة والاعتماد، حيث سنستعرض لحضراتكم ثالث أوراق عمل هذه الورشة، وهي مواصفات مكونات الخرسانة: الإسمنت والركام والإضافات الكيميائية والبدائل المعدنية. يقدمها لكم الدكتور ريتشارد شيسكي، فليتفضل مشكورا. دكتور No, but if we don't start there, we'll have to wait for at least 15 minutes. Is it on?
Okay. 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 It's always difficult to come back from a break as people start filing in. The biggest challenge is that some of the phrases in the United States don't translate well. We have a phrase that we use, it's kind of like herding cats, trying to get everybody back into the room at the same time. So I understand, but I'm going to go ahead and start. I'm going to go from 10:45 to noon, and then we break again for lunch. And I'll cover two presentations as part of that. The first is I'm going to do ingredients, and then we're going to get to C94. And so I'm going to talk about it from the discrete materials standpoint before I get to the composite. And there should be time for questions, and then, of course, during the breaks, I'll be available for questions as well. So this is how I'm going to proceed for several of the presentations. First, I'm going to talk, and this will be the first one here, is I'm going to talk about these materials. Each material has a standard. Those standards funnel down to C94. That should be 94. Then eventually we're going to talk here about sampling. And then we'll talk about testing down here. So this is kind of how I'm going to approach it going forward. So these will be the standards that I talk about. Now, if you recall, I mentioned about the number in the standard being important. The lower the number, the older the standard. The newer the number, the newer the standard. That doesn't mean how long it's been since it's been updated. That means when it was created, when it first was born into ASTM. Now, let me showcase for you this. This is the actual title for ASTM C33. ASTM C33/C33M-13. Those numbers all mean something. C33 is the standard designation. M also stands for metric, meaning it's a dual unit standard. And then the 13 stands for the last time it was updated, 2013. 2012, 2012, 2011, 2014. It gives you an idea when you are downloading, reading, or using the standard, how often it was updated. Now, why is this important? Not just as a user, but as a specifier. So if you're in the engineering community, if you're referencing a document in your contract documents, in your governing document, your building code, and you say this: I want to specify ASTM C33M-13. You want the 2013 one. but it's 2018 and the project is still going. Do you use a standard from 5 years ago, or do you use the most currently available standard? This is the subtlety in writing specification language. The specification language might be use ASTM C33 33M-13 or most currently available, which allows for updates to occur. Because in some cases, the changes in the document can be significant, that you're specifying something that we were doing 4 years ago, but may not even be done now. So that's a key part of this, is making sure you're using the most current standard available. So I'll talk about aggregate, I'll talk about water. Now, 10 years ago, we didn't have a standard on water as a discrete material in concrete. There was cement, there was fine aggregate, there was coarse aggregate, there was pozzolans, there were admixtures, but we actually didn't use water. We didn't have a standard for it. I helped write this standard because not all water is the same. In fact, I will make an argument for you that water is probably one of the most precious and valuable resources that we have, which means how we use water in concrete is also important, where that water comes from. We used to have a standard that said potable or potable water was the only water allowed in concrete. That meant if you could drink it, you could use it in concrete. And that was our quality standard. The problem was, as water became more of a precious resource, the use of other water sources, recycled, reclaimed, reused, some of those you couldn't drink. So we had to figure out how to include that in there, so we had to write a standard for water. I'll also talk about pozzolans here. Notice 618-12A and A, that means it was published in the first part of the year. That's how fast these documents can change. 2010 was the last time this one was updated. 2013 here. So, let's get right into C33. Now, as I go through these, there's going to be a lot of language up on the screen. A lot of language. When you write standards, you can't be scared of the language. There's just a lot of it. Because you have to write it to an audience that you don't know who's going to actually be reading it. Is it going to be a testing lab? Is it going to be an engineer? Is it going to be a producer? Is it going to be a user? Is it going to be a member of the general public? Is it going to be a lawyer? So we have to write these things to a very, very broad audience, which means it's very difficult for us to keep the language short. Now, we try to. Shorter and simpler is always better. But this is ASTM C33. So in each one of these, when I go through it, I'm going to showcase for you at the top the language. We like to define what the standard does. We like to define, we give that definition at the beginning. Specification defines the requirements for grading quality of fine and coarse aggregate. We put them in the same standard. We put fine and coarse aggregate in the same standard. Now, here is something I'm going to talk about as I do C33, what it does and what it does not do. Many of the standards, there are assumptions of what they do. There are implicit things that people believe are part of that. The standard should be written to what they do and explicit requirements. Don't assume anything about the standards. So in this particular case, all ASTM C33 does is it covers grading, deleterious materials, soundness, and methods for sampling and testing. Now, I highlight for you this note here. The specification is regarded as adequate. It may be, notice the language here, may be either more or less restrictive than needed. The specifier should ascertain that aggregates specified or can be available in that area of work. The point here is, that you can write a specification that is so stringent, that is so strict, you can actually create a situation that you prevent the use of any of the available material, locally available. Now, I used to work for an individual that he had a lot of money. And I was scared one day he was going to come into my office and ask me to build him an elevator to the moon. Because he could write a check and he could just say, build me an elevator to the moon. We have sometimes the same thing with people that use the specifications that don't understand that there's not those materials locally available. They have literally out-specified the ability to produce a product. The standards need to create an allowance that says you can specify something, but you have to take into account what is locally available. Now, here's the other part about an ASTM document. This is a subtle part, but very, very important. So, this is language that comes out of the document, what's called the main body of the document. That is what is called mandatory language. Mandatory language. You must comply. Notes are non-mandatory language. Those are meant for information purposes only. They are meant to help the user of this document understand or gain some clarity about its use. In this particular case, this one basically says, make sure that when you use it, aggregates specified can be made available in the area of work. Don't out-specify your ability to produce something. That's a trap people fall into when they use some of these specifications. Now, this is water. Water is an interesting one because, as I said before, we used to have a standard potable or potable water. If you could drink it, you could use it in concrete. The problem was, those of you may be familiar with ready-mix plants, know we tend to shape them like funnels. We don't like water to run off of them because they carry a high solids content, the water has a high pH, and we try to collect all of that water because for no other reason or simply every gallon of water I can collect off the surface is a gallon of water I don't have to purchase. The problem was that the standards didn't allow for that. I wash a truck down, I wash the plant down, that water has to get collected somewhere. Concrete comes back to the plant, I wash the truck out, I reclaim the aggregates, I have all this slurry, I have to do something with that. What do we do with all of that water? Before the standard was written, I couldn't put it back in the truck. I had to discharge it off the property. The problem was I had to balance the pH, I had to pull the solids out of it. We had some issues, and then the other question we asked is, why are we doing that? Water is precious to us. We need to use that back in the trucks. And the other thing that we finally let people know about, the secret, was that concrete really likes high pH water. It does better with high pH water. It's a technical detail, but it's an important one. Concrete actually does better with high pH water. So we were able to showcase that, and we wrote a standard that allowed for that. And here's what it did. It allowed for multiple water sources, fresh water, storm water, recycled water. I could combine it. Now, there were some references in C94 that still allowed for that. We actually had a paragraph in C94 about water. And we said, well, why don't we just make it a discrete product that goes into concrete and it'll have its own standard specification? So that's what we did. We pulled that out of C94 and we wrote a standard specification for water. The other thing that we found out was the old standard referenced the use of these water sources with mortar. And I said, and we said, we don't make anything out of mortar. The big trucks that are produced concrete, they don't produce mortar, they produce concrete. So why are we doing a testing evaluation on a water source on mortar? We should be testing it on the concrete that we actually produce. Put it into concrete cubes, put it into concrete cylinders, and test those, not mortar blocks. Because none of the projects I saw on the drive over here from the hotel to Sasso were built out of mortar. They were built out of concrete. Make sure that when you're writing the standards, when you're making standards, you're making the test result out of the appropriate material. So that's the other thing that we did here. Now, sometimes when we write standards, we realize we weren't able to test everything. So we had to actually write a second standard, which is 1603, Standard Test Method for the Measurement of Solids and Water. We didn't have a method for doing that, so we had to write that standard as well. It wasn't difficult, but we had to have a standard test method to support the standard specification. And those happened in parallel at the same time. But this was a key part of creating this. Once we did this, now, there was always people who stood up and said, we disagree, we disagree, we disagree. And that's okay. They had to make their point. We got to make our point. Take a vote. Everybody, who do you agree with? Everybody agreed with one side versus the other, and we now have the test method. We now have the standard specification. This was so enormously helpful as an industry for allowing the use of alternate water sources besides drinkable water. Now there are ready-mix concrete plants, whereas they may have used 100% what we would call municipal water. You pulled off the municipal water source, the clean drinking water. They may now be only using 10% of that, and 90% of their water comes from stormwater runoff, recycled, reclaimed water. It's a tremendous opportunity for us as an industry to show sustainability, to show a lowered environmental impact on a community. I worked for a ready-mix company. They were doing repairs on the water system, and they cut through a water pipe. And the water pipe was, let me see if I get my conversion right, 3 meters in diameter. It's big, huge, 3 meters. They cut through it. That was the main water supply source to the city. They knew that we were a main consumer of water in the city, and they called us and they said, you're not going to be able to produce concrete for a week. And we said, don't worry about it. I've got an entire pond out here of water. I've got a pond that has 2.1 million liters of water just held that we used back in the concrete. So it was an enormous ability for us to supply ourselves with water. Without this test method, without this standard, we would not have been able to do that under the contract documents for the concrete we supplied. So there was a need from an industry standpoint to put this in there. So somebody raised their hand and said, I'd like to change the document. How long did it take us to do this? About 6 years. Back and forth, writing the document, collecting the test methods, collecting the data, all of those things. About 6 years to do that. And had somebody not raised their hand and done that, we'd still be right now today using the drinking water sources to produce concrete. All right, okay. We're going to talk about cements. I'm going to spend about 4 slides on cements. I'm going to talk about 3 different cement standards. And some of these are older than the other ones. Notice the number, ASTM C150. This is the grandfather of the cement standards. This is the old one that's been there for a very, very long time. In our particular case, it addresses, let's see, how many do I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different cement types. But I highlight for you the ones in yellow because many of these are no longer produced. Many of these cement types, mill left in the entire United States that still produces a type 4 cement. Only 1 mill left in the whole entire United States that produces a type 4 and a type 5. So I've got a 5 available, a 3 available. Well, what do I use for the other ones? It's what's called a hybrid. It's a type 1-2 cement. It's got dual classification. It's a type 1 and a type 2 cement at the same time because of the specification. So Some cements, notice this is a note in C150. Some cements designated with a combined type classification, type 1-2. That's what we use the majority of the cement for general purpose, general use as a type 1-2 cement. Dual classification. So the challenge that we have in that particular case is within the engineering community. When somebody reads the specification, they write a specification that says, thou shalt use an ASTM C150 type 1 cement. Well, what happens when the mix design is submitted and the mix design says, we're going to use 350 kilograms, 400 kilograms, 500 kilograms of a type 1-2 cement? Well, the engineer looks at that and says, well, that's not true. I want a type 1. And you'll say, well, I'm using a 1-2 cement. So now you have to have that discussion, and you have to show them this note with an ASTM that says it's actually allowed. Cement conforming to the requirements for all types are not carried in stock in some areas. In advance of specifying the use of cement other than type 1, determine whether the proposed type can be made available. Remember when I talked about specifying yourself out of being able to supply? This is a key part about this, is this actually gives a note to the user of the document, a specifier. Make sure that the product is actually available in the area you're specifying. I had somebody specify the use of a type 4 cement because we were building a large piece of mass concrete. And they said, and they had read their book and they had been to a university and they had said, well, when you're building mass concrete, you need a low heat of hydration cement. I need a low heat of hydration cement because that's what I learned in school. Well, nobody produces a type 4 cement. But I specified it. But it's not produced. But I specified it. That's the challenge that we've got with some of these specifications, is to make sure we write them in such a way that we give guidance to the user that says, sometimes some of these products may not be available, so be prepared when you specify to allow for that. Oh. Now, this is ASTM 1157. Notice what we just did. C150 on cement to 1157. Look at the description on 1157. This performance specification. You go back to 150. Requirements, frequencies, qualifying, the compositional and performance requirements. So C150 was about chemical composition and performance requirements. If you come over here to 1157, performance specification. This is a performance specification for cement. Now, I'm going to talk about this several times between today, tomorrow, and the next day about this issue of prescription versus performance. Prescription versus performance. And I'll highlight that for you. That all comes to a head when we get to ASTM C94, Standard Specification for Ready-Mix Concrete. This prescriptive versus performance aspect. 1157 is the performance specification for cements. And it breaks it down into these categories. GU, HE, MS, HS, MH, and LH. The nice thing about this is it allows cement producers to produce a cement for use in ready-mix based on its performance in ready-mix, not just based on its chemical composition, but based on how it performs in concrete. Same principle I was talking about with water. Make sure you're testing the appropriate thing. In this particular case, cement 150 was about how the cement performed in cement cubes. 1157 is about how the cement performs in concrete. Big difference there. It was a challenge in writing this 1157. Now the goal in 1157, the gentleman earlier had asked the question about a withdrawn standard. 1157 was written for a purpose of not only producing a performance basis for cements, but also to withdraw C150, to have 150 go away. The problem is we still have 150 and 1157 at the same time. I'll show you what happens there as we go forward when you have to write a standard specification for construction. .1, this is an actual statement out of the document. This is mandatory. This performance spec covers hydraulic cements for both general and special applications. There are no restrictions on the composition of cement or its constituents. Now, I hope this translates well. We have a phrase that we use, don't tell me what to put in the soup, just make sure it tastes the way I need it to. Does that translate well? I'm not sure. The point here is, this one says, just make the soup to taste the way I want it to. What you put into it, we're not interested in. Just make the soup taste the right way. All right, these guys are laughing, so that must mean it's translating well. Now, so here's 1157. Second specification on cement. But we also have a third one. C595, blended performance cement. In this particular case, we take a hydraulic cement and we blend it with slag, pozzolan, or limestone, or with Portland cement or Portland cement clinker, slag or lime. Now wait a second. Can I just take a regular cement and blend it with a pozzolan at the ready mix plant? Yes, you can do that. Some cement suppliers will actually take the cement and the pozzolan and blend it together at the cement mill. Or they will intergrind it with their clinker. Both are acceptable, both are common practices, but you have to take them into account in your specification. In this particular case, this one, 595, is now one of our most widely used standards because of an issue that we have with cement supply. We don't have a surplus of cement. We do not have a surplus of cement. We actually have the other. We have a lack of cement being produced. It's very difficult for us to build a cement mill because of environmental regulations. The last large cement mill built in the United States took 10 years to build. 2 years to construct, 8 years to permit. Actually, it happened in the opposite order. 8 years to permit, 2 years to construct. 10 years to build a cement mill. And as part of their permit, they had to close 2 cement mills in the United States. Same company did. So, we now have people looking at producing cement by blending pozzolans in to produce more tonnage from the cement mill. Well, that means all of a sudden it's not a C150 cement, it's also not a 1157 cement, it's now a 595 cement. This is a big, big issue for us. I'll talk a little bit about this from a sustainability standpoint in a couple of days as well. So, what does this mean? This specification prescribes ingredients and proportions with some performance requirements, whereas performance specifications is 1157 is a hydraulic cement. One is cement, one is a blended cement. So now all of a sudden I have 3 cement standards: 150, 1157, and 595. Arguably, one of those should have been removed, but we didn't do it yet because some people are still using it. So, what that means is I have a statement like this, or this is the statement that we try to put into engineering or contract documents when we're constructing a building. Hydraulic cement shall conform to. ASTM C150 12 or 123, 1157 GUMSHE, 595 1L, 1P, 1S, or T. That's the specification that we put in contract documents, or we like to see in contract documents, or municipal building codes, or for the engineering community to adopt, because this allows for a broad spectrum of cements to be used to produce concrete. Now imagine what would happen if I took this and I put a period right there and none of this existed. Hydraulic cement shall conform to ASTM C150 Type 1. How many hours we're going to spend discussing this with a specifying engineer that material isn't available or doesn't exist, or I have 3 other cements that I could use in producing the concrete available to me. That's why writing the specification correctly is a big deal. Now, arguably, I could remove C150 off of there. I would love to, but that's not happening. So, this is the correct way a specification for cement should be written within an engineering document or construction document, where you look at all of those. Okay. Fly ash, pozzolan, coal ash, and fly ash. There's 3 classifications here, N, C, and F. The key part about here is chemical and physical properties. I highlight for you this here. Its chemical properties are easy. Its physical properties are easy, but it also asks you to make mortar cubes. We don't make mortar cubes out of the back of ready-mix trucks. We make concrete. So this is one of the other things in some of the standards. Now I'm going to highlight for you when I go through these standards the good and the bad. This is one of those aspects that we probably could and should change. Okay, another one. ASTM C260, air and training admixtures. Well, wait a second. Your next slide is C494, which is chemical admixtures. Air and training admixtures are separate than chemical admixtures. Could they be combined? Yes. Why are they different? Think about the numbers. 260 versus 494. Somebody said we need to do an air and training admixture, so they said, oh, okay, that's great, we'll do 260. A couple years later, somebody raised their hand and said, well, why aren't we doing all the admixtures? Well, 260 had already been created, so now they've got 494. Truth of the matter is, air and training admixtures should be up underneath 494. So now we wind up with 2 standards. Air and training admixtures for the use of air entrainment, added to the batch immediately before or during its mixing. It's an admixture. Not that difficult of a standard. 494 here, this is the note. It's recommended that whenever practical, tests made using the cement, the pozzolan, the aggregates, the air and training, the mixture proportions, all be there. So if you're testing an admixture, make the concrete with it when you're evaluating it. A lot of times laboratories like to say, well, we're going to use our standard mix design. There is no standard mix design. The cement, the aggregate, the water, try to make and use the admixtures when you're evaluating them out of the closest available materials that you're actually going to be producing the real concrete with. That makes a difference. Gives you the best possible result. Now, I want to highlight for you, for some reason that's coming up there, this down here, type S. You might be familiar with A's, D's, water reducers, superplasticizers, a type F, a D, a retarder. We had to create something called an S category. Remember what I've said at the very beginning? Technologies were changing. Companies were coming up with new and better technologies all the time. The chemistry industry, the admixture industry, was no different. They were coming up with admixtures that could not be classified under the normal scheme. A, D, B, G, F. But we had to figure out how to get them in the standard. So we created this category, type S. It was for something that didn't meet the other standard categories, but we wanted to include it in the document. So we have a type S. So one of you right now today could say, I have a better idea for how to do an admixture. But it doesn't conform to a standard specification or classification, so that's why we create the category S. The other thing was, I'm going to transition here into ASTM C94, and we're going to talk about that. What about if I had a new product, a new discrete material that I wanted to put into concrete? Now, I always like to say, as a ready-mix producer, chances are you've had a pile of something sitting somewhere. We've looked at it and said, how do I put that into concrete? Well, in some particular cases, we have this issue. There's two that are a big deal for us right now, that are what we're considering. The first is something called returned concrete. Returned concrete. There's concrete left in a truck and it comes back to a plant. Previously to considering this, we really only had two choices. We could dump it out into a waste pile, we could put it in a landfill, or we could take it and try to make something out of it, some kind of block that we would use to stabilize something. That was about it. Well, what would happen if I left it in the truck? I left it in the truck, I added some chemical admixture to it to retard its hydration, and then I added fresh concrete on top of it. Now I don't have to dump it out, I don't have to manage it, and I get to go right back out the door. Now, some of you automatically are thinking this is very scary. This is cause for concern, for performance reasons. There are ready-mix companies that have been doing this for a long time and doing it very well. But we're now considering it as a discrete material because rocks, water, sand, cement, pozzolans, admixtures are all discrete materials. Don't tell me what to put in the soup. Make it taste like I want to. Same thing here, it's another ingredient. Another product that we're looking at, ground calcium carbonate. Ground calcium carbonate. Is that an aggregate? Is that a powder? What is it? We're actually having to write its own standard specification. Standard specification for ground calcium carbonate for use in ready-mix concrete. We're currently writing that right now under the aggregates group, CO920, because we're now looking at that as additional aggregate. So that's my transition into C94, and I'm going to move right into that one now because those were the building blocks for getting us to C94. Okay. That's not the right one. Okay. So, I go back to this one, this diagram here, and now I've got ready-mix right here. So, talked about the discrete materials, all of those funnel into there. So, in this particular case, this is the overview for C94. This specification covers the quality of concrete, specified or specified by the purchaser. Now, here is where I need to make a very clear distinction. Today, we've talked about engineer, specifier, but this document addresses two groups, and two groups only. The purchaser and the manufacturer. That is the only thing it does is define the relationship between the purchaser and the manufacturer. Now the manufacturer is really never in doubt. That's the ready-mix producer. The purchaser, though, can be any number of people. Sometimes the specifier is the purchaser. Sometimes the purchaser is the owner. Sometimes the purchaser is the contractor. But the only thing it does is define the relationship between the purchaser and the manufacturer. Now, years ago, we had a whole bunch of other people involved in the document. We had specifiers, we mentioned engineers, but we've written those all out of the standards because we found out and we determined that really the relationship between the manufacturer and the purchaser are the only ones that count. Because the purchaser, as the name implies, has a direct contract with that manufacturer, the producer. And that's it. So that's the only thing that's mentioned in here, and those are the only people that you will see. Now, what happens in any case where the requirements of this of the purchaser differ from the specification? The purchaser's specification shall govern. Now, let's say that there's a specification for building this building that says you will use 500 kilograms of cement for the concrete. But the purchaser says, I want 550 kilograms of cement. The purchaser's specification differs from the specifiers. What the document says is that the purchaser's specification governs. Now, think about how that affects the manufacturer on the other side, the producer. Let's go the other direction. Construct this building. It says you will use 500 kilograms of cement. But the purchaser says, I want to use 450. I want to use less than what's specified. One, because I know that the manufacturer can do it. And two, I want to manage my costs a little bit better. Well, all of a sudden, the building is constructed, it meets strength, but the engineer in reviewing the documents says, I said you will use 500 kilograms. But the purchaser said, well, I wanted to use 450 and I bought it from that. The engineer comes over to the manufacturer and says, you were out of spec. You didn't follow the specification. I get to raise my hand and go, no, I did, because I did what the purchaser told me. The purchaser's specification governs. That's why we tried to simplify the relationship. Very, very important. And that controls a lot of what's in the document. Concrete, the definition. Remember how I told you how important the definition was? Concrete manufactured and delivered to a purchaser in a fresh state. Not a contractor, not an engineer, not a specifier, not an owner. Purchaser. Okay. So, this is how ASTM C94 is organized. Now, I'm going to highlight for you several categories, 4, 5, 6, 9, 12, 14, 17, 18. All of these, and I'm going to highlight for you some key things in each one of those as we kind of finish up here in the next 30 minutes, is the relationship between the purchaser and manufacturer. I'm going to highlight for you several more times about that. I've talked about that and how important that is, and I cannot stress to you enough how much that simplified the use of this document for the users. Prior to this, and I'll showcase for you a key example coming forward as we go into some changes. Okay. Already, we defined the basis of purchase. Cubic yard, cubic meter. Now, there are some people that say, well, we want to do a half meter, or we wanted to do a 2 meter purchase, or something like that. You had to define the basis of purchase, so we did it as a cubic yard and cubic meter. Of fresh concrete as discharged. The other key part, as discharged from the transportation unit. And here's why that's so important. It doesn't have to come out of the back of a ready-mix truck. It could come out of a dump truck. What about a volumetric mix truck? Volumetric mixing trucks are not included in this standard. They have their own standard. They have their own standard. Now, we like to say that they are a cousin to C94 because whatever changes happen in C94 they make those changes in C685, which is the volumetric trucks. And they are also under C0940 subcommittee from a governance standpoint. So volumetric trucks are not in here, but I can batch concrete, put it into a dump truck, and deliver it to a job site. So that's part of this as well. Now, well, I've shown you each one of the discrete materials. What happens in C94 is we list those materials. It also simplified our document. Before, I actually had to have materials and give all of the cement and then give its specification in there. Now I don't. I just see materials, cementitious materials, ASTM C150, ASTM C1157, ASTM C595, and just list those there. If somebody has a question about that, you can go to that document. It has simplified things for us tremendously to just list the materials. Aggregates, water, air and training admixtures, chemical admixtures, and you just simply reference their standard. So much easier for us. In this particular case, in any given instance, the required dosage may vary. A range of dosages should be allowed. I mentioned this note particularly because it's in C94. We have a lot of notes in 94. And what that means is you will see a specification for an admixture that will say you have to have, the dosage range will be 4 to 6 ounces per hundredweight, or milliliters per cubic meter, or milliliters per cubic per kilogram. You have to allow for a range of dosages. In a lot of cases, somebody will look at a batch report and they'll say, you were out of specification because you used too much admixture. Well, I may have had to use that much admixture because of changes in the raw materials. Note 3, interchanging kinds, characteristics, grades of the materials permitted in ready-mix concrete may produce concrete of different properties. So just because it's allowed doesn't necessarily mean you're going to get the same result. This is that cautionary note to protect the user, producer, and purchaser. All right. This is probably the most complex part of C94 that causes the biggest concern for users of the document. And I mean users of the document, everybody. I'll go over this in detail here in a little bit, but I want you to see the language and how important the language is because it matters. So the first part is, this is how you order concrete. How a purchaser would order concrete from the manufacturer. There are 3 options. Option A, when the purchaser requires the manufacturer to assume full responsibility for the selection of the proportions. Just make the soup. I want the soup to taste this way. I don't care what you put in it. Note 7. The purchaser in selecting requirements should give consideration for workability, placeability, durability. All of a sudden, we're starting to talk about terms we don't normally talk about. Placeability, durability, finishability. Those aren't in the standard. Those are things that are done and determined by the contractor. All of a sudden now we're starting to get other people involved, besides the purchaser and the manufacturer, but I've got a note here that says I need to take into account. So this is basically the producer. This is the performance one. This is performance-based. The manufacturer assumes full responsibility for the proportions. This is performance basis. I want 25 MPa concrete. That's all I will need, 25 MPa. Make that happen. Now, option B, when the purchaser assumes responsibility for the proportioning of the concrete mix and will specify cement content, max water content, and admixtures. This is, if the other one was 100% performance, this is 100% prescriptive. 100% prescriptive. Yeah, I told you I'm going to talk about this a little bit later, but I'm going to give you a great example. My mother, God love her, every time I go see her, she wants to go to lunch. So I take my mother to lunch, as a good son would. We go to lunch, we look at the menu, and I say, I'll have the salad. I just take this out. My mother looks at the menu and says, I'd like the salad, but I'd like to take the onions out. I'd like my dressing on the side. I'd like some extra cheese. I'd like you to put the chicken on the side, but make that grilled. And then, if possible, could you add some extra croutons to it? It's the same salad. Now, 2 salads come. Now, just to let you know, I'm going to pay for this anyway, so it's my mother, so don't worry about that. The 2 salads come. I eat my salad. Tastes like the salad. My mother eats hers, and she immediately says, it doesn't taste right. Now, waiter comes over, and he says, ma'am, what's wrong? And she says, it doesn't taste right. But he says, but I put the dressing on the side, and I put the chicken over there, and I grilled the chicken, and I put the extra cheese on it, and I put the croutons on it. And he made it exactly as she prescribed. But it doesn't taste right. Who's responsible? Who's responsible in that particular case that the salad doesn't taste right? It's okay. You don't have to answer that one. Think of it. Now, let me ask you the next question. When the bill comes, remember I told you, don't worry about that. I'm paying for it anyway. It's my mother. When the bill comes, which one of the 2 salads do you think is more expensive? The second one. Because it was more prescriptive. Now, we'll keep talking about that as we go forward, but this is the issue in the standards, that it allows for somebody to do that, and if they would like to spend more money, they can. In this particular case, the purchaser assumes full responsibility for proportioning. Remember the first question I asked you that nobody wanted to answer? Who's responsible when the salad didn't taste right? My mother. Yeah. Remember that answer when we get to the engineering aspect of it. Because in that particular case, that translates to the specifier versus the producer, the purchaser. So let's keep going. Option C. This is the complicated one. The purchaser requires the manufacturer to assume responsibility for the proportions with the minimum allowable cement content specified. Note 8. What does Note 8 say? Note 8. Option C can be used only if the designated minimum cement content is about the same level that would ordinarily be required for the strength aggregate. What does that say? Wait a minute. You want me to design it, but you're going to tell me what to put in it as well. Now, this is the most complicated one, but right now, this is probably the most widely used ordering option in the standard, is option C. This is our most widely used ordering option in the standard, option C. And as I show you going forward, will probably be one of the most problematic issues that we face, that I face as an engineer in using this document, is this right here. Everything else I can deal with. This is probably the most problematic aspect of the document. Okay. So I've summarized them here. Option A, B, and C. Manufacturer assumes responsibility. Purchaser assumes responsibility. And option C, where it's all kind of together. Most complicated part of the document, and where I would dare say 90% of my problems as a user, as a producer, come from, is right there. Okay, here's another way to look at it. Here's another way to look at it. I've simplified it here. This is concrete performance accountability. Option A, B, and C. Remember what I asked you? The salad didn't taste right. Who's responsible? Under all 3 of these options, who's accountable for the concrete performance? Now, I taught an ethics class one time to a group like this of engineers. of specifying engineers. And I asked them, who's responsible for specifying the performance of the concrete? 300 hands go up. All the engineers admitted that. Now I said, have any of you ever been on a job where you have low strength concrete, low breaks? Low breaks. Anybody ever happened to anyone? Now, I said to the engineers in the room, who's responsible for those low breaks? And not a hand goes up. It's almost as if somebody was holding their arm down. Well, that's the disconnect with the ordering options. Ultimately, the producer winds up being the most responsible for the results every time, no matter how it's ordered. So, in this particular case, who's responsible for how it's proportioned? Well, under option A, the manufacturer is. Under option B and C, the purchaser's got some responsibility as the manufacturer. So it's a mess. So, I offer this as a suggestion, and I also tell you that this is a direction that ASTM is going with their document. We are trying to simplify things to a prescriptive and performance basis. A prescriptive and performance basis, and it will look like this. Option A, B, and C, as I've talked about. Mixed proportion responsibility and performance accountability. Under A, they're aligned. Under B, it's different. Under C, it's different. But when we go prescriptive, we want the responsibility for proportions to match who's accountable for the results. Under performance, we want the proportion responsibility to match who's accountable for the results. If you're accountable for the result, give me direct control over the proportions. Now, from an engineering community standpoint, what does that really mean? How many engineers who do not have the ability to produce the concrete will actually look at this here? Nobody's going to do that. In fact, this is where you really want to be. We're migrating the document to look like that. That's going to be, remember what I told you? 90% of our problems come from this section. It's also going to be where 90% of the fight comes in trying to make the change. This is a fundamental shift for us in this document. All right. So, measuring materials. The first is tolerances. This is the other subtle part, but critically important to making concrete, is the tolerances by which it is measured. Now, a mistake that we made years ago in the document was about something called weight versus mass. Weight versus mass. And this has to do with something that we did not recognize years ago with ASTM in C94, was that it's an international document. Mass is the international and correct term for how we would measure the material. Not by weight, it's by mass. So we had to make sure, and we've been writing that term out of the document for the last several years, about writing the term about weight out. It's measured by mass or volume, not by weight. Well, we had to give a tolerance on that measurement. And these are the accepted tolerances, 1%, plus or minus 3%, plus or minus 2%. Now, interestingly, is the aspect of minus. I have had, as a producer, I have had people come to me and say, you are stealing. You are committing an act of theft or fraud when you underweighed material. Well, I was weighing up thousands of pounds of that, and my scale accuracy sometimes can read under. That's why the minus tolerance is also important, because it protects the producer. It's a plus and minus. Everybody likes getting more, but in some cases you could get less because there's a minus tolerance there. And that's allowed. We had to take that into account from an accuracy standpoint. That's why it's plus or minus. The other thing here is water. I highlight for you water because it takes into account multiple water sources. Water added to the batch, ice added to the batch. I think being here and working in the Middle East and me being in Texas, our climates are very similar during the summer. It is not uncommon for us to see 30 degrees C temperatures for 6 months out of the year, and well above 32 for about 3.5 to 4 months. Not uncommon at all for us. So ice is very common. Water occurring as surface moisture on the aggregates. Water introduced in the form of admixtures. Now, that's listed in the document. The truth of the matter is, do I really take into account the water in admixtures? Not really, unless I'm using a very, very high dose. But I have to account for all of these water sources. Again, now imagine here, water added to the batch. Imagine that's 2 sources itself. Maybe there's municipal water, maybe there's recycled water, maybe there's storm water there. You have to have a computer system that can account for that as well. If you're doing it by hand, you've got to be able to track each one of those water sources there. Okay. All right. Mixing and delivery. Now, I've got 3 types that are allowed here. One is central mix, one is shrink mix, one is truck mix. Central mix, mixed in the big drum and then dumped into a dump truck, dumped into a ready mix truck. Shrink mixed, slurry mix, or the components are mixed dry and then dumped into something. And then finally the truck mix, dry materials into the back of a truck, and the drum turns and mixes there. So I have to account for all of those as well. But what this really does is it addresses each one from a uniformity standpoint, making sure that as that material is batched, it is uniform from load to load to load. Uniform in terms of what? Uniform in terms of its mixing capabilities. Does it mix the concrete in a uniform manner? Not does it produce strength in a uniform manner, but does it mix the products uniformly each time? Now, a couple of things here. Time and drum revolution limits. Those are there. I'm going to talk about those a little bit later. Temperature limits. Producers shall deliver the ready-mix concrete during hot weather at concrete temperatures as low as practicable, subject to the approval of the purchaser. In the document, section 12.11, it does not have a maximum temperature. It says approval of the purchaser. Now, under a note, now, here's the key parts. Language in the document, mandatory. Note, non-mandatory to provide information. In some situations, difficulty may be encountered when concrete temperatures approach 90 degrees. Additional information may be found in ACI 305. That's all it says. It doesn't say there's a temperature limit of 90 degrees. It doesn't say there's a temperature limit of 32. Unfortunately, some people read this document and say that it does. Oh, in ASTM C94, it says there's a temperature limit. No, there is not. It says you may encounter problems, and that's it. But the document clearly says in the mandatory language, approval of the purchaser. Means the purchaser sets the limit. I can tell you right now, I produce concrete with temperatures well above 32 every day. All right, so batch ticket information. This is a listing of what is required. This is a listing of what can be required, but not. The list on the left side, company, serial number, date, truck number, job designation, all of those kind of things. That has to be on the delivery ticket for C94. It gives the purchaser definite information, and more importantly, if there's a problem with a load of concrete, that mandatory list, the mandatory list helps me identify where that problem may have occurred. Sampling and testing. We're going to talk about this in another presentation, but here are some key parts. So now all of a sudden, I'm starting to mention a couple other groups that are involved. Because the contractor shall afford the inspector all reasonable access and assistance. It's in section 17. All of a sudden, the purchaser and the manufacturer aren't really involved in sampling anymore. So all of a sudden, I have to mention these other groups. Tests of concrete will be done by a certified technician. I cannot stress to you enough. I cannot stress to you enough how important and what an impact this has of saying the person who is testing and sampling the concrete must have a certification to do so. We have millions of dollars invested in these buildings, and they're tested in these cylinders and cubes. And if that one person does not have the appropriate ability to do that correctly, I now have millions of dollars at risk. That's why that person must have a certification to do this. That's also why the samples must be taken in accordance with. That's why that sampling section is so important. We'll talk about that, I think, tomorrow a little bit. Now, sampling and testing. There are only actual 4 tests mentioned in C94. 4 tests, that's it. Slump, or slump flow, strength, air content, and density. That's it. Now, the purchaser can specify any other test they want, but these 4 are the required ones in C94. Just 4 tests. The other thing that is critical in this document is something called check tests. So, somebody shows up, they say, we want to measure the slump. They measure the slump. Oh, it's too wet. It's too high. It's too low. Reject the truck. The document has an allowance for an additional check. The first test result does not constitute rejection. We realized years ago we were throwing away millions of cubic meters of concrete off of one test. So we said we want a second test. We found out that the quality of the concrete actually got better and more concrete got placed. We weren't throwing away as much. Now, strength, we're all familiar with that one. I highlight for you right here. If a specimen shows definite evidence other than low strength of improper sampling, molding, handling, curing, or testing, there is a list of things I can give you to make concrete weaker. I cannot give you a list of things to make concrete stronger in testing. So we put this actually in the document. It says all of these things can essentially make concrete weaker, so be aware of them. Okay, last couple of minutes here I want to show you, add for you some recent changes that we've made in C94. These are recent changes. And these are significant. The first was this one here. The standard mass of a bag of cement is 94 pounds. You'll notice that it says in the United States. We recognize the simple fact that this is now an international document and that 94 pounds is just 94 pounds. We just picked that number. There's a great history on that, but it really had no technical merits whatsoever. And so right now we had to change this to this. Cementitious materials in bags may be used when requested by the purchaser. If you want to use a bag as a means of measurement, just tell me how much the bag should be. This one here, section 19, low strength. This is what it used to say. In section 18, if it fails to meet strength, it had this very long description here. An agreement on a mutually satisfactory adjustment by a panel of 3 qualified engineers. Its decision shall be binding. That has no business in a document, a standard specification for ready-mix concrete. But it had been there for close to 60 years. But nobody ever had any concern about it. But when we asked the question how many people were using it, nobody could ever say they've ever used it in the history of the document. The people who put it in the document were no longer available to tell us why it was in the document, but we found out that nobody had ever used it in the document. So we said, let's just take it out of the document, which is exactly what we did, and we put this in here instead. When it fails to meet strength, the manufacturer and the purchaser shall confer. Manufacturer and purchaser shall confer to what adjustments, if any, shall be made to mixed proportions, production process, or testing procedures. Those are basically the three big categories that can affect the strength of concrete. So if you have a problem with it, look at those. And then we gave in a reference here to ACI on how to address low strength test results. All right, this is on the 300 drum revolution limit. We had a specification in there that said when the truck hits 300 drum revolutions, 301 drum revolutions, you could reject it. Concrete was no good. Well, we started doing some tests and we found out, here's a very big graph, 301 drum revolutions right here. This is the time. This is the strength. And this is the strength limit. What happened was, and we found out that we could go over 300 drum revolutions and still hit the strength that we wanted to. So we weren't rejecting concrete. So we actually had to write that into the standard as a change. The discharge of concrete shall be completed with 1.5 hours before the drum has revolved 300 revolutions. This was the way it was written. The way it was written. The purchaser shall state any drum revolution limit as to when the concrete must begin. So, I work in a particular climate that, in some cases, I want the concrete off the truck faster than that. In some cases, I want the concrete off the drum. It can be there for a while because the temperatures are cooler. I have a lot of pozzolans in there. It doesn't have to automatically come off at 301 drum revolutions. So we changed the standard that says if you want to put a drum revolution limit in there, just specify it. All right, I think I'm kind of running out of time here. Yeah, do I have on the schedule? Okay, just stop at 12. Okay. All right, so here's the other change we're making. What about 90 minutes? We also had the 90-minute clause in there. It's 300 drum revolutions or 90 minutes, whichever came first. Well, 90 minutes is a little bit more complicated because 90 minutes involves hydration. 90 minutes involves chemistry. We haven't made that change yet, but we're making the argument about it. Because with the use of, if you control the chemistry, you control the concrete. Admixtures, pozzolans, different cement types, different ambient temperatures, all can affect that. We have to create an allowance within the document that recognizes that. Sometimes putting in what I would call an arbitrary limit truly does limit what you can and cannot do in the field. And so we have to write that into the standard. I'm going to go ahead and stop here with a couple of minutes left because I think I have time this afternoon as well that I can keep going. So I'm going to hand this back and then I'll, okay. No, that's okay. I've got time this afternoon. I'll just stop here.
Yeah, okay.
I've got a big block this afternoon.
كان yeah.
Yeah, I have a full hour this afternoon, but I can keep going.
No, you have all the time.
Yeah.
I need only 1 hour.
Yeah.
But yeah, there will be some.
Yeah, I'm going to go from like 1 to 2. I'll finish up that presentation.
Yeah.
Goal,
Yeah.
and then. I'll
No,
take
very
some
good,
questions.
very good. Now, me coming after that, it make it concentrate on the difference.
Okay.
Which is very nice.
That's good.
وين احطها بديع على هذه؟ ها؟ أنا ارسلت ايميل كل شيء احتياط. قلت له ابدا بالكمبيوتر حقي. فيه مشكلة يا وديع. وديع. أبو وديع. دكتور محمد. وش شو اسمه؟
طلعت سحبت الفلاش.
لا الحين رجعت له مرة ثانية.
ستارت
هذه
wait content okay so you would like to repair it
تراي موجودة على مرسلها ايميل.
يا apparently انه الحين هذا هو الدستور. انت بدو سحبتها بدون ما تسوي لها شو اسمه ذي.
احنا رحنا انسى هذا انسى هذا. I'm using now
هلا يا مرحبا.
السلام عليكم. شلونك؟
مو الشرائح، نعطيكم المحتوى حتكون موجودة على الموقع.
نقدر نروح للايميل. ها؟
والله خلينا نضع مكتبي شغل الكمبيوتر هناك.
اوكي.
هنا نرجع.
Down response constitutes acceptance. Tell me what to put. Tell me how you want the taste.
similar question. Let me show you on the slide. So there's two.
You know, this is my question, but I don't like to ask in the session because, you know,
It's okay.
This discussion, it will be, if it open, it will not close here. It will take.
No, I think that's good. And in fact, you should ask it because I've got a little bit of time left.
Yeah.
I'm supposed to go for an hour in the next session,
And also, I don't like to ask this question because if I ask it, maybe it will be reflect on the time for this.
well, what I will do is, let's see here. So this is my aggregates, right? So this was C33. Where did I talk about that change? Oh, I know where I did that. So that was changes, recent changes here.
Why I ask is
this one here,
yeah.
This one.
Yeah.
So what I'm going to do is
recycle.
Yeah. All right, so I'm going to take these two slides. I'm going to copy those. I'm going to come down to this one here that I'm working on now.
In the next session.
Yep. I'm going to keep going. And then I'm going to put them right here, and we're going to talk about them.
You know why I ask this question? Because I have some colleagues as a researcher. I am associate professor in university before coming here. Working in this research, and you use the waste concrete and make crushing again just to use again in the concrete. This is, I think, this is what you mean by recycled. But
yeah.
The problem that they faced in the test of the final product, the strength is not as we expected.
Nor will they be. So if you're using crushed concrete as an aggregate.
Yeah.
Okay. So here's the issue. So all of a sudden I get a little bit aggregate, but I get this huge paste.
big one here. Okay. Assalamu alaikum wa rahmatullahi wa barakatuh. Okay. Yeah.
حياك الله.
الصور احنا وانت.
حياك الله والله. خلصت انت؟ سلام.
مرحبا انا وانت يا دكتور.
حياك الله.
دكتور عبد العزيز المحاضرة بتاعتك، بس أنا هناخد بقى سوفت كوبي عشان عندنا اجتماع دلوقتي فهضطر أستأذن.
أسلم والله.
وناخد بقى سوفت كوبي بإذن الله. حضرتك هتبقى افيلابل أكيد على الويب سايت أو بإذن الله.
إن شاء الله.
بإذن الله. فرصة سعيدة جدا يا دكتور.
بارك الله فيك.
أي حاجة؟
سلامتك والله.
لينا لقاء بإذن الله. الله يخليك. لينا لقاء
بارك
بإذن
الله
الله.
فيك. حياك الله.
سلام، كيف حالك؟ شلونك؟ اخبارك؟ الله يبارك فيك.
شو اخباركم؟ عسكم طيبين؟ احنا اكثر والله. شو اخباركم؟ عسكم طيبين؟ حياك الله والله. لما سالتني السؤال خلاص هنا شركه وش اخبارك؟
مشتاق طمنا عنك كيف امورك؟
وش اخباركم؟
دائما ابعث لك سلام مع ناصر.
ونعم.
دائما كل ما تشوف الدكتور.
انت الحين جازت لك البحر وجاز لك ما تبغى الرياض ولا
نيجي هيك سلام ولا يروح.
حياك والله. حياك الله يبارك فيك.
ما تيجي الشرقية؟
والله من فترة رحنا قاعد نفكر فيها اليوم. من العام الماضي آخر مرة أكثر من سنة. لا هو العائلة كانوا يسحبوننا بس الحين الظاهر الحين صاروا يسحبونك أبعد شوي. لا أنت بس موجود ها؟
أنا هنا موجود إن شاء الله. بكرة وبعده إن شاء الله.
الله يحييك. أجل بنشوفك إن شاء الله. خلنا بس بخلص من هذه يلا لينك.
يعطيك العافية. حبينا نسلم عليك.
حياك والله.
اقول لك بعد شوي علشان هو يبغى يطلع في الصوره بس موجود.
اوكي ما يمشي.
غير التشكيل غير التشكيل غير التشكيل عشان ما يقول التفكيك.
ما في صوت؟
ما في صوت. في صوت في صوت.
ايوه.
أكثر من صورة تعال من هنا أحد كذا كيف بعد هذا من قفا أشوف أنا
وجد إيميل؟
خلاص ما ناقصنا إلا
خل ما كني ما راعي لك أنا صورة بعد ها
كذا باين انك انت مسوي الرسمي مرة ما يجي
يلا صورة براحت
حاضر
كذا كيف طلعت؟
هذا البوت كان عشان اسد هذاك
مصر هنا يعني مصر طيب بصراحة عشان ننظمي امسك الهواء يعني اقعد اطقطق هنا اقعد اطقطق باين باين يا تزوير خلاص
Okay. We'll continue. It's always nice when people come back after lunch to hear you. So thank you all for coming back after lunch. I appreciate that. I had several questions during the breaks that I want to come back and revisit one subject before we continue on, because there was enough questions about it that I think many of you would benefit from hearing about this. And this was with this change that happened in ASTM C33 that we're currently working through with recycled aggregates. So I wanted to bring back up these two slides. So this is the slide where we addressed it in section 3.2 under the sand aspect. This is the definition that we are proposing for recycled. As I mentioned very early on, the definitions matter. And so if you'll notice how we've defined the term recycled. We didn't define recycled aggregate, we defined the term recycled. Diverted, separated, or removed from the solid waste stream, processed and returned to use in the form of raw materials or products. I'll give you an example of where that works in an actual quarry. I go to a quarry and I take big rocks and I make little rocks out of them. Much like throwing a plate on the ground, when you go to pick up the pieces, you pick up the big pieces, but there's a whole bunch of small little ones that I have to sweep up. The same thing happens at a quarry. Every time we take a big rock and break it into a small rock, we have a whole bunch of small pieces. Those are typically looked at as waste. Now, from a resource standpoint, we look at that and say, how could we put that back into use? That is a recycled product when I do that at a quarry. By definition, we just had to define it that way. Now, the second part of the questions that came up had to deal with this section here, section 9. When I said recycled aggregate, did I mean crushed concrete? Is that the same thing? Now, in this section 9.1, the yellow phrase is the only thing that we've changed. The phrase that's printed in white already exists in the document today. Now, ironically, when we were in here talking about this, the comments and questions that came up about this were identical to the comments and questions that have come up in making this change at ASTM. In fact, some of the questions that got asked, I would have wondered, are we in an ASTM meeting because they're the same questions? But what about recycled crushed concrete? What about crushed concrete? Is that a recycled product? We have issues with that. We have questions about that. We've had problems with that. In this particular case, if I take out the yellow phrase, coarse aggregate shall consist of gravel, crushed stone, air-cooled blast furnace slag, including crushed hydraulic cement concrete. See Note 6. It already is allowed in the standard for use. Now, Note 6, I didn't have the ability to do it quickly, otherwise I would have. Note 6 is about 6 sentences long about the precautions that you should take as a specifier or user of hydraulic crushed concrete. It gives those precautions. It gives those warnings. It gives that necessary information for a user to be able to safely integrate hydraulic crushed concrete into the production of concrete. Now, that's one of the things that we are starting to migrate to in the document, the standard documents, is the inclusion of notes. Before, there maybe used to be 1 or 2 notes. Now, a document could have 10, 12, 20 notes in it to provide additional information. Those of you that have ever read the ACI code, know that there's a code, and then there's also a commentary. The commentary explains the code, because we want to keep codes small and with the least amount of language possible. But in many cases, we have to give a lengthy explanation as to what it means. That's what the notes are begun to do inside of the document. It's okay to have those. It's okay to have commentary, as long as you make it very clear what is mandatory and non-mandatory.
what is required and what is not required. Those two things are very, very important in the document. We actually had a problem that I highlighted for you in ASTM C94 with the sack of cement weighing 94 pounds. We had people, that was a note. That means it was non-mandatory. Over several decades of that note being there, people used it so often to reference the weight of a sack of cement that became an industry standard. And by default, it became a standard, even though it was never intended to be. So when we tried to change that, it was very, very difficult. So I want to just make sure I went back over this. Does anybody have any questions on this part of it? Because now is a great time to ask on the aggregates or recycled crushed concrete. I'll be more than happy to address that as I go on. Questions? If not, you can always catch me during the break as well. Okay. Yes? Okay. His question was, is there a separate test for hydraulic crushed concrete aggregate? Is that your question? Yeah, is there a separate test method or something here? Great question. I'll answer it in two ways. First, ASTM C33 looks at it as an aggregate. Remember when I went back to the very first slide for C33, I talked about what it really did? It talked about gradation, deleterious materials, and sampling and testing. Now, so the question is, well, I have another test I would like run, or I have something else I would like tested with that. If that's the case, you specify that. But if it conforms to ASTM C33 in terms of gradation, deleterious materials, it's an ASTM C33 aggregate. Now you may say, well, I have a concern over alkali silica reaction. I have a concern over its compressive strength in concrete. There's nothing that prevents you from asking for that. But if it meets ASTM C33 for deleterious material and grading, it meets ASTM C33. But if I come to you and I say, well, I want to use crushed concrete as an aggregate. Here's my gradation, here's my deleterious material certification, and I've got those. You may say, well, I want to see this compressive strength history of its use in concrete. There's nothing that says you can't ask for that. And as a person with experience in it, I would say you absolutely need to ask for that. There will be a possibility it could fail if I use the same criteria. Answer is yes, but that same possibility exists for failure with the other aggregates. Let's say I have a new aggregate, a quarry source, a new sand source, and it passes ASTM C33. Does the same possibility exist for failure in concrete? I would say probably not as much, because the hydraulic crushed concrete has a little bit more some challenges with it, but the same possibility for failure exists now. ASTM C33 is a qualification for aggregate. It's not a qualification for the concrete that uses the aggregate. Does that make sense? Yes, sir.
ACI 555, the use of recycled concrete, fresh concrete, he found that the absorption of recycled sand or aggregate can be avoided or can be overcome by using fly ash or natural porcelain or slag. We found very good result. Even we can overcome the alkali silica reaction. We can, because the calcium silicate, aluminum hydrate, this reaction will. So they found if you use fly ash or natural porcelain will be very good.
So his comment was ACI 555 is the Committee on Recycled Crushed Concrete. Their research showed, and I'm familiar with it, that with the inclusion of a pozzolan, fly ash, or others in the concrete that uses the crushed hydraulic concrete, you can mitigate some of the absorption and ASR issues that you might face. No doubt the research is correct. The challenge is to make sure you've actually made the concrete with it, because I was giving an example, I was having a conversation earlier with somebody. I've produced concrete with this. It worked great in the lab. The problem was when we got to the field. Have any of you ever seen a pile of hydraulic crushed concrete? Crushed, screened, aggregate, 1-inch aggregate size? In Texas, because of the heat, we sprinkle and water our aggregates. We use the evaporative cooling to drop the temperature of the aggregates. Do you know what happens when you sprinkle a pile of hydraulic crushed concrete? It actually will begin to reharden. And then you'll take the front loader and you'll go to scoop it up, and it will break it up, but the problem is it doesn't break it up back into those nice, neat little screened 1-inch aggregate size or 25 millimeter size. It makes a 50 millimeter aggregate. Now, what happens if I put it in my overhead bin at my ready-mix plant? I've got a bin up there that holds several tons. And I get a little bit of rain in there, a little bit of moisture from the aggregates being sprinkled. And I shut the plant down because something breaks or we're done for the day. What happens the next day in that overhead bin? It sets up a little bit in there. And now I've got to get that out of there. So from a production standpoint, there's whole aspects of using this product that are not covered in the standard. And these are the practical aspects of being a producer. So that's the other thing, is no standard can cover all aspects of the production or the quality of the materials. It can do everything it can to minimize the mistakes and give you the potential to have the highest quality possible. But you cannot write a standard to minimize everything and maximize everything. There is always inherent risk in it, and that's the best that we can do, is write a standard, write a specification that presents the most acceptable amount of risk. Not the least, but the most acceptable. And the consensus of the group is what determines what that acceptable risk level is. Make sense? Yes, sir.
There is some companies like they have their research to elongate the temperature. You say 32 degrees within 3 days and 2 days and like this. But is the ASTM have the standards for this research?
So, he said, what if I have a company that has done the research on improving a standard? Temperature, shrinkage. What's the mechanism for taking that research and putting it into ASTM? Is that your question?
Yeah, because they say we have the product, but you should test it before using it.
Yeah.
But we want standard.
Okay. So, it's a very nice question, and I'm going to use that as my lead-in to right here, because that's exactly where we are. I'm going to go back and start with this 300 drum revolution in 90 minutes. I can tell you, as a user, as a producer of concrete, I was on a project for developing a light rail system, 50 miles of light rail, above grade light rail. And we had a problem there. We had one inspector. They were rejecting trucks like that. 301 drum revolutions. Concrete's no good. Concrete's no good. 301 drum revolutions. Concrete's no good. We're throwing away thousands of yards of concrete, let alone millions of dollars. Get caught in traffic. Something like that happens. So we did the research. Our company did the research. And we produced these graphs right here. And we said, hey, you're rejecting concrete here. This was my design requirement, 6,000. But I was getting strengths, 8,000 at 200 revolutions. I was getting strengths here, almost 9,000. And here's the trap. Here is the trap. If you look at where the concrete was rejected at 300 revolutions, here's 350, here's 400. What's the trend from here to here to here? The strength is going down, clearly. That gives somebody the power to say, see, I told you, the concrete's bad. The concrete's getting weaker as the revolutions are going up. And I would say that is an absolutely correct conclusion to draw from this, except that this was my design requirement. Yes, the concrete decreased from here to here. It's 8,000. The requirement was 6,000. This was our own research. We had to bring this to ASTM. I had to say, this is a poor standard to have, 301 revolutions. Now, I don't think anybody... Now, let me give you an example of how things get into standards that shouldn't be there. 300 revolutions. Does anybody know where that came from? Anybody even want to guess why it's 300? Why is it just 300? Why is it not 310 or 298? Why is it 300? Because the time that this was inserted into ASTM standards was 1942. The average ready-mix truck used to deliver concrete had one speed, 6 RPMs. The average delivery time in the largest metropolitan market that supplied concrete in the 1940s was New York City. The average delivery time was 50 minutes. 50 minutes times 6 RPMs is 300 drum revolutions. And that is how it got into a technical standard in 1942. But it has no business being in there because it has no technical or scientific basis. But to remove it, now this is your cautionary tale for writing codes and standards. To remove it, we had to come up with a tremendous amount of scientific and technical data to remove it, even though it got put in there for no technical or scientific reason. So in this particular case, as I mentioned before, we did the exact same thing. Now this graph may look complicated, but there are some interesting data here, and we're going to talk about both of those. So one, we talked about the rejection, but this green line is also critically important because this tracks the time. Because in the standard, we tied time and drum revolutions together. And this was a change that we needed to make. So, I talked about this one here. The drum has revolved 300 drum revolutions. Now, look at what's in white that we haven't changed yet. Completed within 1.5 hours or before. So, we tried early on to change them both at the same time. That was not possible. I was explaining earlier as we were chatting about sometimes some of my phrases don't translate well. Here's another one that may not translate well. We tried to eat the elephant in one bite. Does that translate well? Okay. So we had to break it up into smaller pieces to make the change. So here we changed this first, and now we're working on this 1.5 hours. We're working on the 90 minutes. Now, this is what we currently changed it to, that you can specify what other drum revolution limits you want. Now, the interesting part about this is, I didn't include all of the changes. We actually created a loop. We created a loop. If the purchaser doesn't specify the time limit, the manufacturer must specify the revolution limit. If the purchaser doesn't specify the revolution limit, the manufacturer must specify it. Now, why would we do that? This is the details of writing a good specification. Why would we have to create a closed loop? Because let's assume the purchaser does not specify the limit. Well, now it's on the job site. 300 drum revolutions, 350, 400, 450, 500, 600, 800. We all know in this room at some point that concrete is not going to be placeable. That's why we put the closed loop on it. To keep people from keeping a truck out there for hours upon hours upon hours. We also have the same kind of thing of the manufacturer. Hey, I have a very, very, what we would call hot concrete. It's going to set up very quickly. It's a patch or repair concrete. It's going to gain strength very quickly. I want it off the truck quickly too. That's why it's a closed loop. Yeah.
Mega projects, sometimes the client is afraid to have the same amount of concrete from one manufacturer. So you select 1, 2, 3 manufacturers.
Yes.
So when you say about the responsibility, and I want just to know about who's responsible that when we select a specific standard, and we faced a problem with concrete and everything. So what is Tim talking about this?
Okay, so his question was, we have a project that has multiple suppliers to it. Who's responsible for those kind of things? I'm going to talk about this tomorrow, or maybe the next day, I can't remember, about the aspect about strength measurement. Okay, strength measurement. I will make this statement to you here, because it's not only my belief, but it's supported within the standards, that the cylinder of concrete is not there to evaluate the strength of concrete in the structure. It is there to evaluate the performance of the concrete as specified for delivery. And that is a massive difference in the way we look at concrete. The cylinder is there and sampled off of the truck to represent and make sure that the concrete delivered complies with the strength specified. We make a relationship over here to what it is in the structure, but it is not the structure. It's different size, it is a different shape, it is a different curing environment. It was under different loading, it was under different creep, it was under different shrinkage, all of that. So who is responsible? I've been on those projects where the project has been so massive, there was 3 different suppliers, all supplying the same mix design.
So we can use the same standard.
The same standard. That's why I like standards from an industry impact standpoint. They give you an assurance that there is a minimum quality level being met by everyone. It creates a fair playing field. Yes, sir.
Richard, now maybe there is misunderstanding about what you mean by 300 revolution and 90 minutes. I don't understand it.
Okay.
It is, you mean Los Angeles revolution or transit mixer?
Transit, okay.
His
question was on the revolutions. What did I mean by that? The revolution was not the LA abrasion test for aggregates. Another. This meant the drum revolutions of a ready-mix delivery truck. How do I count that?
How do you count it? You must have counter.
The counters are on the ready-mix trucks. There are counters on the trucks.
We don't have it here, sir. We don't have it. We don't have it here in Kingdom. We don't have it.
Okay, and if that's good, you don't want the counters. You don't want the counters. That's good. Good for y'all. That's excellent. Yes, sir.
Excuse me. Standard and code are avoiding to specify the concrete temperatures, like fresh concrete temperature and maximum heat of hydration and temperature differential. Can we have explanation for that?
For temperature hydration?
For maximum temperature of heat of hydration, and for temperature differential, and for fresh concrete temperature, like you said.
So he's asking about temperature of fresh concrete. I'm going to address that tomorrow. I'm going to talk at length about concrete temperature as a practitioner, as an engineer who's operated in what I would say are very high temperatures. Probably not Saudi temperatures, but very high temperatures. I think that is one of the biggest problems I have faced as an engineer, as a materials scientist, is convincing people about the irrelevance of concrete delivery temperature versus the importance of concrete structural temperature. We'll talk about that tomorrow, and I'll put together a case for you tomorrow. And if I don't address the question, your answer then, ask the question again tomorrow. Okay? Okay. This also came up of, within ASTM C94, how do we address things like ASR or ACR? Alkali silica reaction, alkali carbonate reaction. How does the document address those? The simple answer is the document does not. It does not. You remember the 4 test methods I told you that it addresses? Strength, slump, air content, and density. That's it. Those are the 4 performance results that ASTM C94 addresses. ACR and ASR are actually being addressed by a completely different document. They're being addressed by something called 0950. Look at the title. The subcommittee is Risk 0950, Risk Manager for AAR. The document is New Guide for Reducing the Risk of Deleterious Alkali Aggregate Reaction in Concrete. It's addressing all of them. Alkali aggregate reaction. ASR, ACR, and whatever other reactions come out of the research community that somebody discovers tomorrow. It's broad enough to approach that. But the other thing is, it's a risk management document. That's what this is. It's a flow chart that as you go through, you ask the questions and it tells you what test methods or what test method results you should be concerned about. So if you have an issue with ASR, this is the document you would look to. Not to ASTM C94. Not to ASTM C33 on aggregates. Not to ASTM C150 on cements. The test methods that are prescribed in this are on concrete, mortar bars, those kind of things where you can test your materials relative to ASR, ACR, and those kind of things. So this is how we've chosen to address that. We've just said, let's not bother with it inside the document. Let's put it as a standalone document. Surprisingly, that's how we solve a lot of our problems and we create more progress. Because if your entire document hinges on improving this section because of a new material, you slow down the whole document. Take it outside, create a new document over here. That way the community that's interested in that. And I'll give you a great example. ASR, boy, we had some great researchers, academics, and material suppliers that knew about that. But they didn't know a whole lot about making concrete. But they knew about ASR and ACR. You put them in a room like this, and let's say this group over here knows everything there is to know about ASR and ACR. But this is C94. This is 0940, and we're voting on making a change to the ready mix document. This group over here knows nothing about ASR and ACR at all. Now let's take a vote as to whether or not we should make a change. Guess what happens? This very important subject matter that this group over here knows a lot about is either of no interest or this group doesn't know enough about to actually vote on, and so maybe the change that needs to be made doesn't get made. So let's create a standalone document for this group to address, and we reference it. That's how you adjust the standard to deal with it. Makes things much more efficient. Now, I talked about this one here briefly. Yes, sir. Oh, okay. He asked a question about AASHTO, A-A-S-H-T-O. In the U.S., we have ASTM, we have ACI, we have AASHTO, and we have the Corps of Engineers as kind of some governing entities that write specifications and documents. 2 of these I would like to say are open to the public, ASTM and ACI. Anybody can join. There's no restrictions. There's no way to prohibit somebody from joining. If you'd like to be a member, you pay your money and you're a member. Corps of Engineers is a military document. The people who govern that is the military, and you have to be part of the military to change it. AASHTO is you have to be part of a municipality or a government entity that builds a road, street, or bridge. I don't get to be part of that. No matter what my expertise is, I cannot give input to AASHTO. So to me, the best 2 groups, ACI and ASTM, are the public ones. They're also the fastest to change. The fastest to change. I always like to say the other ones change at kind of a... if ASTM and ACI are glacial in their rate of change, AASHTO and the Corps are geologic in their rate of change. They're just incredibly slow and they don't change. Now, return concrete. This is an excellent example of somebody who was working in Chicago. They raised their hand, and I say raised their hand, they sent a note to us at ASTM, and they said, I'm an engineer in Chicago, and I had a producer tell me that they were supplying concrete to my job that used returned or top-loaded concrete. Now, what that meant was they had 1 meter, 2 meters left on the truck, comes back to the plant, they place fresh concrete on top, mix it up, send it back out to the job. That was top-loaded or returned concrete. Engineer says, is that allowed under ASTM C94? They asked that question. They sent a note. 2 things happened at that time. First, a general member of the public, a non-member, asked us a question. That happens a lot. But because they sent it in through a formal process, we had to answer them. The answer was no. But then the second thing happened. We said as ASTM C94, Section 0940, I was the chair, why don't we address that? Isn't that an important issue for us as an industry? Because as a producer, I'd been doing that for a long time. I wasn't cheating anybody. We told them about it. We were really good at doing it. We did it for 2 reasons. 1, it saved me money. And 2, it saved me more money because I didn't have to dump it somewhere. I didn't have to waste it. So we asked the question, then we started talking about it, then we realized as an industry, for the community that we work in, from a sustainability standpoint, every meter of concrete I didn't have to reproduce were liters of water, kilograms of cement, kilograms of aggregate that I didn't have to use, arguably all of which are non-renewable resources. We had an opportunity, we had an obligation as an industry to take a leadership role from a sustainability standpoint and write a standard to address it. What a wonderful opportunity for us as a concrete industry to address that and take advantage of that opportunity. So, the first attempt we had, the first mistake we made, was we tried to include it in the ready-mix standard. That was a mistake because it took us about 2 years to realize it's another material, write its own standard. Because there's going to be a product, a material, a year from now, 5 years from now, somebody's going to discover, somebody's going to use and say, we can use this in concrete. We'll write another standard for that, and it'll just get included as a line item. So right now, this is exactly where we are in writing this document. This is a very contentious issue because everybody admits we need to address it, but we're struggling with how you measure it. In practical terms, just in this room, imagine that I had a truck that had 1 meter-ish left on the truck. How do you know that? How do you know what's left on a truck? Does anybody in here have a volume meter that they somehow magically have? Because if you do, you've got the billion-dollar idea. Because nobody can figure this out yet, of how do you evaluate what's left in the drum. You could weigh the drum. All right, I got to weigh it. Somebody says weigh the drum. Right? So we've talked about this before. Hey, this is an ASTM meeting. So we've weighed the drum before. We've weighed the drum afterwards. We've put meters underneath the pedestal. We've put meters underneath the wheels. We've put meters underneath the shocks. We've done a lot of this. This is not a small thing. Plus, we're in business. How do we measure this kind of stuff?
We can by volume. If we count what is the content of this concrete, and when we put it, we will calculate the volume, and maybe by volume we will transfer it to mass.
Over here, he's got guesstimation, and then we have another one that we call SWG, scientific wild guess. So,
I'm asking about this, the same question. Remember in the lunch break, About the batching by volume, I need your recommendation. Batching by volume, not batching by weight.
Yeah,
Can you give an idea about this?
Let me talk about batching by volume and batching by weight tomorrow. I'm going to address that in a couple of the other slides. My point is that for this, these are materials that you can incorporate within ASTM, within the documents, but the same questions that we've got here. Do we do it by volume? Do we do it by guesstimation? Do we do it by estimation? Do we do it by weight? That is an ASTM meeting, and that somebody brings forth an idea and says, this is the way or this is not the way to do this. And then we have to quantify it, then we have to put it in writing, and then we have to put it out in front of everybody to read. What we just did here in the last 2 minutes is exactly how an ASTM meeting is conducted. We just have a little bit more data that we bring forth to do it. Yes? So his question was, is this returned concrete or rejected concrete? Okay, so let's talk about that a second. So returned concrete, by definition, what we're talking about is I have a 9-meter truck that goes out to a job site. 8 meters are discharged. 1 meter comes back on the truck. I batch on top of it, and then I send it out. That is returned concrete. That is top-loaded concrete. We actually have a limit as to what you can do, and by there we set the limit at 50%. No more than 50% of the volume that goes out the gate can be more than returned concrete. Okay? We've got the tests and those kind of things to prove. That's returned concrete. His question was also, the second part was on rejected concrete. So now 9 meters goes out. It goes to the job site. The slump is too high. It's rejected. Send it back. Could that be returned concrete and go out the gate? Well, no, because it would violate the 50-50 rule. Could I place that somewhere else? Well, maybe. Some cases we do. I do. I have a job that's over here, and in some cases it's no different than it's over-ordered concrete. Is there a place I can put it that has a lower specification than what it was rejected for? A quality manager may know someplace on the way back or close by where they could place that. That's how I would address that. But this particular specification is only for returned concrete as the way I've defined it, not rejected concrete. Make sense? Okay. In some cases they are the same, but our challenge with an ASTM as we're writing this specification is that 50-50 limit. We had to draw a line somewhere. His thing is we should treat them the same. Now what we have done from a practice standpoint, truck comes back with the full 9 meters, rejected. I took 7 meters of it and I made blocks at the plant. 2 meters I left on the truck, added 7 to the top, and sent out the door. So his question is, after I mixed it, did I do some test methods? Absolutely, and we write those in the standard. The same concerns that you have now of you must verify slump, you must verify strength, you must verify air content. You must provide both batch tickets. You must inform the purchaser that it's coming. You have to tell them you're doing it. Now, my experience with that is 3 things. When you tell them you're bringing back you're going to supply return concrete, they want to pay less for it. They're going to blame every problem that they have on it, or they don't want it. Now, some contractors over here, the 4th one, they're going to say, we do want it. Thank you very much, because we couldn't get concrete from anybody else, or you were so busy. In a big, busy market like we have right now, if you call up a ready-mix producer in the state of Texas right now and ask for concrete, they will put you on they will put it on the books, and it'll be 3 weeks. We have a 3-week backlog right now. That's how busy we are. Are you busier here or less busy? Yeah, we're 3 weeks out from ordering. I'm going to talk about what that does to your material supply chain here in the next couple of days. Okay, that's kind of where we've gotten to with ASTM. I talked about ASTM as an overview of an industry, as a standards organization. I talked about the discrete materials, each one of the components that becomes into concrete, and then I talked about the concrete document, ASTM C94. Tomorrow, I address sampling, testing. I'll do plant certification, but I think tomorrow I start off with the top 10 myths in concrete. They've given me a block of time on that. I don't think it's enough time to cover all of them, but I'll cover probably the first 5, one of which has to do with high temperature concrete, and I'll really dive into that pretty deep. Some questions came up during the break about availability of the presentations. Can we get access to the presentations? Can we get copies and those kind of things? I think our organizers will address that, be able to tell you where you could get those or how you can get copies of that. Of course, you can always get a card from me during the break, and I can just send me an email, and I can give you a spot where you can download them as well. But I think SASO will probably be addressing that, of how you can get copies. Yes, sir.
Mm-hmm. Specification for ASTM C150.
Yes.
And they found that C3S content in the C150 had board range more than 62 or 65. But while H2 had only limit for 57, and they found that H2 is better for deterioration, for the strength, for many things. If you make it, the limit is 57 for C3S, not a board range like 62 or 65. So C3S is important, and they found H2 is better. So most of the DOT project in Orlando, Tampa, they take the cement, which approved by H2 more than ASTM C150.
Yeah.
Thank you.
His question is I told you about the 4 organizations that created specifications. It's really only 2 of them, which is AASHTO, 3, 2.5. AASHTO, ASTM, and the Corps of Engineers. Corps of Engineers usually defaults to AASHTO, so there's really only 2, ASTM and AASHTO, and they are different. And here's the problem that creates. AASHTO, as I mentioned, is very slow to change and reluctant to change because you have to get input. You have to be a member to give input. And those of us that want to change it can't because we're not members, nor are we allowed to be members. ASTM, on the other hand, allows anybody to be a member and allows anybody to give input. Why is that so important, even though that he said, well, AASHTO, somebody found this to be more specific. The problem is, AASHTO, if you draw a pie chart of how much concrete AASHTO actually governs, it's a very small slice of the whole pie. So if I'm a cement producer, if I'm an aggregate producer, if I'm an admixture producer, and I want to produce a product that conforms to where the majority of the concrete is consumed, I'm going to use the ASTM standard. And where we run into problem is he mentioned a DOT, Department of Transportation. In the states, we have a Department of Transportation at a state level, and then we have a Department of Transportation at the federal level. And what happens is, one of those DOTs, the state DOT, says, we want our specification this narrow. Well, ASTM specification is this broad. Well, what does that mean? From a material supply standpoint, I don't want to have to stock 2 different products. So, we stock in aggregates is the number one place this happens. Aggregates is the number one place this happens. Somebody has a very narrow gradation. A DOT does. But ASTM says your gradation can be this big. Performance in the concrete doesn't matter. The aggregate is here versus here. I don't want two stockpiles of aggregates. Anybody here in the quarry business? Go to a quarry and ask them if they would like to produce one aggregate or two. And they will tell you, we want to produce one. If I'm in the concrete business, the ready-mix business, do I want to stockpile two different coarse aggregates or one coarse aggregate? One coarse aggregate. One. I'd rather have a 20,000 ton stockpile of one aggregate type versus a 10,000 stockpile with an aggregate gradation like this and a 10,000 stockpile with an aggregate gradation like this. I have two inventories. I've got two quality problems. I've doubled everything. Yes? Technical wise. So, let me switch hats. Okay? Let me switch hats. So, okay. So technical wise, they put on.
And fine aggregate, also minimum 2. Everybody in this hall knows that.
It's okay to have multiple aggregates. I'm not saying you can't.
One single site.
I'm saying from a specification standpoint, simplicity is when you have two different specifying organizations. Somebody specifies a gradation with this tolerance, and somebody specifies with this tolerance. It's not about how many aggregate sources, it's about the tolerance on each source. That's the distinction I'm making. I apologize if there's been confusion. I'm trying to say that we
are talking about well-graded aggregate.
Right.
Not gap-graded. Okay. Another question, sir, excuse me, about what said our friend, the rejected concrete.
Rejected concrete.
You know, here in Saudi, we have two reasons of rejection. One is the high temperature of the concrete. The other one is the slump out of tolerance.
Temperature slump.
Okay. Can we find anything in the ASTM how to solve this problem? For example, if I have slump, let's say allowed 12 centi, I get 15. Can I add some cement or some aggregate to improve this one? Do we have any code or any system? It is haram, we say haram, to solve, to throw 9 cubic meter because the slump is too much. Okay, haram.
All right, so let me address this question about rejection based on slump in the last couple of minutes that I've got here before I turn it over. So, if you remember, when I was addressing ASTM C94, I talked about something called a check test. So this is exactly what has happened numerous times before. My truck would come out to a job site, somebody would pull a slump cone, and they would say, you are rejected because you're either too low or too high. Let's talk about each case. So first, let's talk about too high. My slump is too high. I am rejected. Well, the first thing I'm going to do is I'm going to ask for my second test because I'm allowed under ASTM C94. That allows me to keep a truck there and ask for a second test. Now, there are two things I can do to that from a quality standpoint. I can check and say, is there a time limit? If there's no time limit, or there is a time limit, am I under the time limit? If I'm under the time limit, move the truck back in line. Move it back a truck. Because I still have time. And the slump will decrease over time. Now, second thing is there are chemical admixtures I can use. There are chemical admixtures I can put in the truck that actually reduce the slump. Those have to be approved, but that can happen. On the low end, I'm rejected because the slump isn't high enough. It has a slump range. And it was below the minimum. The first thing I would do is I would look at my batch ticket and say, do I still have water that can be added? If I still have water that can be added? Oh, okay. Oh, okay. I thought he was going to come up at 2. Okay. If I'm under that, do I have water that can be added? And it says so on the batch ticket. If so, I add the water back, I mix it in, and I measure the slump again. I have the same issue with air content. Low air versus high air. I want my second test. The standard allows for that. There's a very specific line in there that says the first test, if it passes, constitutes acceptance. If you don't, you are allowed to do an immediate retest, and as part of that retest, you also have to do a resample. You do not sample out of the same wheelbarrow that you sampled the first one that was rejected. That's a key part. The standard allows for that. That's a big, big aspect of that standard. And as a producer, that's the one part of it that we are never, ever, never going to let get written out. Because that helps keep my concrete on that job and hopefully going into the structure. Yes, sir.
Related to the aggregate again. There is some type of aggregate, they think the last material. That it's big, it's bigger than what's they require. And the different uses, not in concrete. So different uses of aggregate. So when we're talking about the test, I thought you said maybe 4 main tests or about this. But in actual, there is another standards. They have many other tests like freezing point, like boiling point, So when we will want to go to the aggregate, so is there any standards that it's explaining more widely about this aggregate?
Yeah, his question is about, well, what about all the other test methods? What about all the other standards that are out there? Because there are dozens of them that measure freeze-thaw durability, shrinkage, all of those things. You can say, I'm going to use it to evaluate my aggregate. I'm going to use it to evaluate my concrete. There are dozens of those types of standards that are in there that are not referenced from another one. They're just a standalone. Because as an engineer, an architect, a specifier, I may have a particular concern over the creep of concrete. But creep isn't mentioned in C94. How do I address it? Well, you say, I want my creep, and I have my standard that I write for creep or for shrinkage. And you just reference the ASTM test method by which you want it tested. That's the great part about this, is it doesn't restrict any architect, any engineer or specifier from addressing their particular concern. All ASTM C94 does is say, this is the quality level of which you will produce concrete. But if you have a test method that you want that concrete to achieve, you have to specify that in addition to C94. Does that make sense?
Yeah, but you know that here in Saudi, because they cannot find it, they stay on what is talking about this type, for example, let's say aggregate. So they are searching about the Europe standard, they are searching about this standard, and here in Saudi, exactly, you can find multi-projects. One of them going with Europe standard, one of them is going with. So is this like, it's meaning that ASTM, they cannot cover all things about, for example, let's say aggregate. I'm not talking about widely. So ASTM, they don't have, let's say about, because there is a mega project, Metro Riyadh. So they use mixed of standards. And I don't know if we can go with ASTM lonely or what.
Yeah, I don't have an answer as to that, because that's a Saudi issue as to which standards they adopt. I think there was the voluntary, and there was another term that was used.
For example, we have a test, we are a laboratory. And so every time we are going with the client, they're asking us about the specific standards, like Europe standards. And every time they have different tests. For example, when I say sieve analysis.
Okay.
So between ASTM and the Europe, it's different because the number of the sieves are different.
Yeah, I understand your pain in dealing with multiple standards. I do. If I had a magic wand that could wave, I cannot stress to you enough. I gave you my example. I've got the Corps of Engineers. I've got the AASHTO. I've got ASTM, and I got an ACI guy over here. I've got to contend with 3 of them. And in most cases, when I see an AASHTO standard that shows up in a specification, I wind up calling the engineer and I'm saying, you realize this is not a highway project. I've got an AASHTO specification that will show up on a structure, on a parking lot, on the paving around the structure. Well, I'm an old AASHTO engineer and we specify AASHTO. It doesn't have any relevance, and I've got to call them and go, we're using ASTM on this. Is that okay? Oh, okay, I didn't know there was an ASTM. Or somebody will say, well, I used to work for the Corps of Engineers, and I want to use a Corps of Engineers standard. Well, we don't use Corps of Engineers standard outside of the government or the military. So, I mean, there's those kind of things in these conversations that happen. So I know where you're coming from. I've dealt with it. And unless there was a magic wand you could wave and go, this is the way that the world's going to work with one standard, which it's not. It's just something we all have to deal with. So, I mean, it's...
Yeah. For me, when I purchase, for example, instruments, equipments, about these standards. So somebody asked me about another standard. So I cannot find it in ASTM. So how can I do this test? Because I should purchase another equipment that is applying for, let's say, another standard. So it's making payments.
I always encourage them to go to the one that you know and that you have the equipment for. I've got to let the next speaker come up. I'll continue to be here for the next 2 days, and we can continue to have the conversations and ask the questions. But that's my part for the day. So thank you very much. Yeah.
مساكم الله بالخير. والحقيقة في عدة ملاحظات، يعني ما أعرف الصوت واضح؟ الصوت واضح؟ في عدة ملاحظات. أولا نعتذر عن ما حصل في قضية الغداء. يعني يبدو البعض ما حصل، ما جاء فرصة يلحق على الغداء، يعني هذه كانت خارجة عن إرادتنا ومفاجأة لنا حقيقة في الموضوع ذا. إن شاء الله تحل من ناحية بكرة، يعني ما يكون فيه المشكلة هذه. الجانب الآخر يمكن أيضا في عدة أسئلة عن موضوع المحاضرات وتوفرها. احنا إن شاء الله حتكون جميع المحاضرات متوفرة على الموقع اللي سجلتم عليه، اللي هو على الصفحة. فيعني إذا ما هو اليوم، يعني قبل نهاية الورشة إن شاء الله حتكون جميع الأشياء موجودة هناك على شكل PDF وبإمكانك تنزله يعني. فإذا هذه إجابة عامة، لأن أكثر من واحد يسأل السؤال هذا، فحتوفر للجميع، حتكون متاحة، فقط تدخل وتعمل داونلود. نعم. الملاحظة الأخرى بالنسبة، حصل أيضا تغيير في برنامج اليوم. يمكن لاحظتوا أنه كان المفترض أن الدكتور، يعني يمكن إذا أنتم متابعين الجدول، يعني إذا ما شفتوها طبعا تكون كويس، بس أكيد شايفين أنه حصل تغيير. نعم، فهو مقصود ومتفق عليه حقيقة. كان مفترض أن الدكتور عبد العزيز الغيمش يتكلم ما بين الساعة 11:20 إلى 12، فعملنا ترتيب أنه دكتور ريتشارد يكمل، وبعدين دكتور عبد العزيز يأخذ مواضيع متصلة يعني. فحصل تنسيق بين المحاضرين، ولذلك قبل ما أقدم الدكتور عبد العزيز، في برضه ملاحظة أخيرة. يعني كان في من الأشياء الإيجابية في من ضمن المحاضرات اليوم، كان عن قضية تشكيل اللجان في الASTM. وكان في أيضا السؤال الأخير اللي طرحه الأخ عن قضية المالتي، موضوع تعدد المواصفات. طبعا احنا أشرت له اليوم في محاضرة الصباح، تكلمت عليه. دي مشكلة نعاني منها احنا في ساسو، وانتم الآن بتعطينا مثال آخر هناك. بالتأكيد ده ما هو الحل الصحيح، يعني احنا لازم، وبالتالي ده بالمناسبة إذا تحب تكتب لنا على الموضوع ده عشان بس ناخذ إضافة، لأنه هذا هدف أن نتخلص من الازدواجية المواصفات. يعني هذا ما هو حل صحيح، ولذلك لاحظت حتى في كلمة المحافظ اليوم كان يشير لنفس النقطة هذه، عملية توحيد المواصفات، وبقدر الإمكان نمشي مع المواصفات العالمية مثل في الموضوع ذا على ASTM، ما لم يكن في سبب وجيه للتغيير. يعني احنا ما نقصدنا ناخذها بغض النظر إذا في شيء مضبوط أو ما يتفق مع البيئة، لا، بالتأكيد إذا في سبب أو في شيء للتغيير يصبح شيء محدد وواضح، إنه المواصفة اللي يأخذها مثل ما هي مع استثناءات، ممكن تضع ملحق appendix توضح في جميع الاستثناءات بحيث يكون متفق عليه، ومكون على طريقة اللجان اللي تعمل التوازن ما بين المنتج، مثل ما تكلم، حيث أنا ودي نفس النموذج ده اللي هو إلى حد ما هي سياسة ساسو. بس عندنا مشكلة، وهذه اللي ودي أسألكم عنها، إنه ما حد بيتبرع لنا ويشارك. إحنا يعني على الورق السياسة المتبعة عندنا إنه مشاركة القطاع الصناعي، الأكاديمي، المستهلك إلى آخره، نفس الكلام اللي بتشوفه في الASTM. فعليا ما حد حيجينا، فذلك من الصعوبة نعمل الأشياء كلها. فحقيقة باعتبار إنه الجميع هنا الآن مهتم بالخرسانة، وزي ما قلت لكم الصباح أنتم أصدقاء الخرسانة، فيا ريت اللي له أي اهتمام بغض النظر عن ايش عمله الفعلي. يعني احنا في الاخير بالتاكيد نحتاج المعلومات تقدم، انه يتواصل بانه مهتم ان يكون في الفرق الفنيه واللجان الفنيه اللي تعمل في تطوير هذه المواصفات. بالاخير لازم نعمل توازن بالتاكيد، يعني ما بين اذا كنت تمثل زي يعني بنفس الفكره انه يعني الصناعيين ما حيكونوا مثل المسيطرين على، يعني ما حيكون في اي قطاع هو مسيطر على الجميع، لابد من توازن. بس احنا الان ودنا بالمهتمين واللي لهم يعني راي وفهم في الموضوع ويحبوا يشاركوا في اللجان يرسلوا لنا المعلومات هذه. اشكركم، وعوده الان الى الدكتور عبد العزيز النغيمش، جامعه الملك سعود. حقيقه ما انا طلبت من الجميع يقدم نفسه، بس انه بصفه عامه الدكتور في الهندسه المدنيه، له يعني جمله من الابحاث والبراءات الاختراع والميداليات ما شاء الله يعني، وايضا الخبره العمليه في الامانه وفي جامعه الملك سعود. وحيقدم يعني جزء من محاضره الصباح اللي هي عباره عن المقارنه ما بين مواصفات ساسو اللي عندنا هنا وما بين الASTM، ثم بعد ذلك يعمل ايضا مقارنات ما بين مواصفه ساسو في الخرسانه، طبعا في الاول في الاسمنت والثاني في الخرسانه مع الASTM. فانتم شفتوا الASTM، الان حتشوفوا ايش الاختلاف بس او ايش الفروقات. نقدمها الدكتور. تفضل يا دكتور، يعطيك العافيه. المشكله هذا معين هو شغال ولا ما ادري بعد؟ شغال ولا ما ادري؟
هذا اللي شغال.
لا ما شغلت.
نعم شغال هذا حق الكاميرا. هذا المربون.
انت وين؟
بارك الله فيك. السلام عليكم. أنتم جوعانين وأنا جوعان، لذلك يمكن بعدين أصير أسوأ حالا منكم، لأني لا I have to give some energy without the privilege of lunch. So tomorrow for the lecturer, at least give the lecture. I thank SASO for giving us the opportunity to share with you and also to hear from you on the standard and the way forward. You will see right now, okay, that SASO at a crossroad. There are too many standards for the same material and for the same practice, okay, and it needs to be sorted out, okay. This will be highlighted in this lecture. Also, you will see that sometimes it is not an easy. Somebody will think that why I don't adopt, okay. and we have the chance to adopt ISO. We have the chance to adopt ASTM. We have the chance to adapt European norm, okay? And it's all logical, okay? And we are moving that direction. Like for management system, for laboratory accreditation, nobody talk about anything other than ISO 9000 or ISO 17025. Agreed. Nobody is debating because globalization, testing by lab anywhere should meet certain strict standards so that the recognition of their testing will be appreciated in other countries. So nobody is now debating, I have my own accreditation standard for laboratory. Everybody is accepting, although telling you that ISO 17025 is not an easy standard to apply, okay? It is very lengthy, very demanding and all of that, but you have to accommodate. Now, when you go to materials, okay, another aspect which is mentioned by our lecturer in the morning, Dr. Richard, that, you know, if you produce a material, okay, you have to use it from elsewhere. So if it is complying with the standard, with an internationally recognized standard, it makes it simpler for everybody, okay? Historically, Dr. Ahmed mentioned that historically we are more tuned toward ASTM standards and ACI code. This is in education, okay? We teach based on American standard. So this is influencing things. But yet, in some specification, some contract, if it is done by European design officer and consultant, you will find European standard because they are familiar with that, okay? The problem here, we don't have an enforceable yet, an enforceable building code. So that opened the, but if there is a condition in the contract between the owner and the consultant that Saudi standard should be the reference standard, then this will solve the issue. Let's navigate without some energy, okay, you will find some of the detail I'm talking about later on difficult to digest, but I don't expect you to digest them. I just want to emphasize certain point. This is the laboratory issue here, okay? When you have implementation of Saudi building code, okay, you need to have the standard and the code, of course, but also the code enforcement mechanism, and most importantly, you need the quality infrastructure. What are these? Okay. Well, and this done by municipality, the plans review, inspection and testing, okay, you have to have standard. So if I have multiple standard for the same test, then this is creating a problem for me and too much demand on me as a provider for the testing services. Also, okay, we can see it here, educational training them. Do I need to train them in all standard? Well, it doesn't make sense, okay? Well, certification. Well, you will see it in ASTM C94. It has to be, he has to be certified. Certified against what? Also, having the people who is doing the certification and the recognition of their certification is not an easy, okay? So you would like to pull from international expertise, okay, somebody who is working in some other country, okay, and he is certified according to ACI or ASTM, he will come in here and he will make use of that certification. So this is the background of me preparing this presentation, okay? You know, that doesn't make sense for the same material to have multiple standards, okay? Multiple test methods, okay? So SASO recognized that, okay? And they are working toward harmonizing and streamlining these standards. We can see it here, okay? This is, I got it from SASO, okay? And I was surprised. I thought I'm going to talk about one ASTM standard and compare it with ASTM, okay? So with the GSO standard, which is adopted by as Saudi standard 1068, okay? There is also European norm or standard. There is the ISO. This is, creating problem for the testing lab and also for the specifier and for the academia. Which one we teach, which one we emphasize, okay? So here you can see, okay, that some of it, okay, is written on it mandatory, and this is optional. But this is not a solution. This is creating too much demand for nothing, okay? So if this is proper, okay, then you don't need to have the other ones, okay? If it is not proper, you need to make it proper and get rid of the rest of them. Make it easier for everybody by having a standard which is credible standard that anybody can or everybody need to use, okay? Well, this has to do with this one, okay? Even in this standard, there are contradiction, okay? The last one, okay, the European norm adopted as ISO 206, GSO EN 206, has a provision in it, okay, saying that it is the governing standard, or should be the governing standard, should supersede. تشيل المواصفة ال 585 and replace it with this standard. الحين هذيك موجودة إلزامية وهذه optional. optional تقول إنه مفترض إنه هذيك تصير إيش؟ obsolete. So this need to be streamlined. Similar thing we have it in cement. We have ASTM standard, and also we have the European standards, okay? So it is a lot of effort trying to comprehend and compare and all of that. So this is need to be streamlined. Of course, when you look at the local practice here, okay, the governing standard for cement is ASTM. There was used to be a Saudi standard, SASU standard. It was superseded by this new standard, which is GSO 1914. Okay. So I will not talk about the old one, which has been superseded. Okay, but with that standard, most of the cement factory in the kingdom produce cement according to ASTM C150. Okay, so that did not impact the industry much. Okay, everybody was still when they build their factory, their target is to produce cement according to ASTM 150. We have seen that ASTM 150 now is suffering in the state, but in here it is thriving. Okay, but not all the 5 types. 2 types, type 5, which is the sulfate-resistant cement, and type 1. And type 1 can be type 1 and type 2, of course. So I did not, in the comparison, we did not, I worked with Dr. Abdurrahman al-Hazemi, trying to see the compare. What do we have compared to ASTM? If everybody now is, in the building code specification now, in the project, everybody is referring to ASTM C150. So what is this? What is the new standard, which is 1940? Well, we did the comparison, okay, and we reached the conclusion, okay. We actually did the comparison between the ready mix and the cement. Now the cement one, okay, is the same as ASTM 150. Okay, it is taken based on ASTM 150 with very minor modification. One of the most important modification was observed by Dr. Abdurrahman is on the testing method. They compiled all the testing method in another standard, which they called it GSO 1915, testing for cement. but also these tests, for the most part, are compliant with ASTM test method for cement. So this saved me the presentation this morning, that there is nothing to compare between 1914, okay, and ASTM. It is almost the same standard, okay. Well, this gave me the chance to devote the effort into making the comparison between ASTM and GSO 585, which is 1068 Saudi standard, okay. Well, we, as an overall, just to have some sense of what I'm going to talk about, it is نسخة مختصرة أو مختزلة من ال ASTM standard. It is an abridged version of ASTM, an older version of ASTM, because this standard, okay, this standard was developed and adopted in 1995. So it is almost 20 years, okay, since adoption and never been updated, okay. So there is no update, okay, for the standard, okay. But since it was abridged, most of the changes in ASTM standard was not affecting the standard, because it does not cover all the detail of the standard. Well, just highlighting some some comparison between the two. Well, is it any good to have GSO 585? Well, I looked at it from different criteria. Well, the scope, of course, is the same. The references, we'll see that the references at that time, they did not develop the references, so they said it will be included later and never been included for the past 19 years, okay? Well, simplicity, of course, since it is an abridged version, most of the detail, or some of the detail has gone, so it is, of course, simpler, okay? Completeness, well, if you are an abridged version, completeness will be affected. So, يعني اكتمال المواصفة ما هو موجود يعني، بس في الغالب مغطية أغلب المواضيع. So, completeness, okay? Detail and clarity of provision, وهذه نقطة مهمة وصارت في السنوات الأخيرة، إنه صارت ال ASTM standard مثل ما قال الدكتور ريتشارد، ال ASTM standard صارت تحط نوتس توضح لك الإيش عملية، يعني القارئ يقدر يستفيد من النوت هذه إذا كان ما عنده الخلفية الكاملة عن الديفلوبمنت حق المواصفة، وش تعني هذه إذا كانت فيها علامة استفهام، وهذه مرة مفيدة لعملية يعني لعملية الامبلمنتيشن. ما هي ملزمة الاكسبلانيشن هذه أو النوت، أوكي، بس مفيدة جدا في عملية فهم المواصفة as a specifier and in case of dispute. A relevant standard, of course, a relevant standard, okay, you'll find them some provision in ASTM not relevant to the kingdom or the practice of the kingdom, and it's still there. So if you adopt it as it is, okay, it is an additional effort to understand it and decide that this is not relevant. So when you try to manage it, okay, you need to consider this point. Of course, consideration of local practice, ASTM, okay, does not consider the evolving local practice, okay. We don't have the limit of an hour and a half and used to be 45 minutes in the ASTM standard. We go for 2 hours right away. And our weather is not friendly, and yet we are going to 2 hours, because if you go to the 45, they used to be 45 in the summer, you will not do ready-mix concrete in Saudi Arabia, or most of Saudi Arabia, okay? So this, because of lack of regulation, that industry developed, and it showed that they can deal with this one, with the admixture, with the retarder, and they can produce concrete in the summer as good as in the winter. So, this is some of the ASTM now is removing some of these restrictions. So now it is some of the condition now is accommodated by ASTM and in ACI 305 for hot weather concrete. Well, maintenance update, well, this is what Dr. Ahmed mentioned, okay? We have a problem here, okay, that the maintenance and update and the people who are doing it, okay, are not there, okay? So you get stuck with a standard, okay, without being updated since it is adoption, okay, some many years ago. So if you link it with a lively standard, okay, make the effort of updating much simpler. But it is still going to be demanding endeavor. Well, this is a summary, so I will go to the detail. The detail that Dr. Richard did not mention, I'm giving it to you here, but you don't need to read it. Okay, I'm just emphasizing with color, okay, the comparison between the two, okay, and sometimes highlighting some of the detail which, if you adopt ASTM, it should not be there, okay. Like this one is a clear cut, nobody can dispute this one, okay. This is an explanation that we have dual unit in ASTM, and if the dual unit, you cannot use them interchangeably. If you use SI units, stick to SI units for everything. If you use the US customary units, pound, inch, stick to them throughout. This is irrelevant and confusing to somebody reading it here who is not familiar about the practice in the state, okay? So this is irrelevant section of the standard that should not be, okay, I should not be bothered with. On the other hand, okay, you know, in JSO, it is a brief description of what is in there. Here, there is some disclaimer warning about the effect of fresh concrete and of safety and all of that, okay. You know, it evolved, why it is here and all of that, it is a history, okay. But it is not there in GSO. It doesn't hurt to have it in here, of course, okay. Well, this is the interesting condition of the standard. This is the reference standard. ASTM, you have a complete reference standard. It is there, lively, updated and all of that. Here you have a standard to be decided later. But this is to be decided later. Some of it has been decided, but since the standard was not updated, okay, we are still stuck with something which, when I see it, I dismiss the standard right away, okay, that this standard is not current or, you know, can be implemented. The issue here, okay, about reference document, sometimes ASTM refer to American standard, okay, and American practice. So here, some of it here, we have either a local document like Saudi Building Code, which is based on ACI, which can be the reference instead of being the ACI 318, okay. Sometimes there is also some detail, other document, NIST, this is for calibration and all of that. This is too detailed to be included as part of your local standard, okay? In the state, there is a background for that, of course, okay? When you go to the terminology, okay, well, here, some of it, okay, you will have some terminology, okay, which is peculiar to the state. Here they don't know it. So if I have it in here, a shrink, I will create confusion about it. So you need to address this one. In GSO, okay, since we don't have a standard terminology for concrete, they try to mention all the detail for the terminology in the standard, which was proper, okay. So you see that it is more than ASTM because they don't have a standard for terminology. They are trying to cover that in the standard itself. Okay. Basis of purchase. Okay. Well, this is the confusion dual unit issue. Okay. You know, cubic yard, parentheses, cubic. I mean, you cannot afford to do that. Okay. Here it is a clear cut, okay, that it is the fresh concrete in metric. So this is a simplification which is warranted. There is some detail here, okay, how to measure the volume, okay, which is not covered by the GSO. You know, yeah, meter, but how I calculate, how I measure that this has this volume, okay. ASTM clearly state that because lawyers at the door knocking. I mean, if you don't have some clear-cut procedure for measuring in case of dispute. Here, we trust the supplier that he is providing us with the, if it is 9 cubic meter, yes, 9 cubic meter, okay. Materials, well, you can see it, that's the problem here, that they're saying relevant Gulf standard, okay, and also they are specifying 2 types of cement, okay. Some of it does not make, I'm highlighting this, does not make sense, okay. Rapid hardening in this environment is never been used and is part of the standard, does not make sense, okay. Well, ASTM standard, it is there, okay. And now the cement and water and all of that, they gave the specification or the limit for water, but they did not give a chance to use alternative source of water. Although this accommodates brackish water, well water, which is not a potable water, this specification, but the recycled water and all of that is not covered by the GSO. Okay. This is ordinary information, okay, and here, although it is 19 years old, okay, recognize only 2 methods in specifying. One, it is prescriptive, and the other one is performance. But the performance is not what you think. It is more like option C of ASTM standard. You know, yeah, you are responsible about everything, but please give me this minimum cement content. And you mentioned something in the state that the 90% of specifying concrete is with this option C. I think here it should be 100%. But here the standard, okay, give some strength grade if you want to specify with the strength. And this is a similar thing we are doing. I am working with the municipality of Riyadh, and they are implementing a scheme for ready-mix concrete, which monitor the quality and trying to create harmony by the ready-mix concrete industry in Riyadh. And what the municipality did is something like option C of ASTM. Yes, you are responsible about everything, okay, but demonstrate to us that you can achieve the strength with this cement. We find that some people will push the border and they will have a problem. So we put that limit, okay, based on experience here, but it should not be less than this amount. We know that this amount will achieve that strength, but not over margin of the strength. So for the same mix, C35, for example, okay, somebody will probably use 330 kilogram per meter cube and succeed if you have a clean aggregate, very good control on all of that, okay? But if somebody else, without this proper control, good quality of material, try to achieve that, he will not be able to meet the strength requirements for that. So it is, you know, the standard itself. I don't think it will solve the problem. There got to be somebody who you know. Yeah, in big project you have the consultant which is verifying that, but for small project there is nobody controlling the quality. Okay, so and you know, SASU, the municipality, they have a role in ensuring that the concrete arriving at this construction site is meeting the minimum strength requirements. So this is option A. But option B, okay, here we have here a specified concrete mixture, which is a prescriptive type, okay. He will specify the mixer, okay, but nobody is now specifying, the proportion of aggregate other than it should meet the ASTM standard C33, okay. Here, an ASTM standard, there is a disclaimer here or statement here that even if you are achieving the strength for the strength option C, even if you are achieving the strength, okay, you cannot reduce the cement content. And this is, a confidence for the purchaser that, over-optimizing is not there. Tolerances in slum or slum flow. Well, and slum flow is a new terminology, okay, came with the self-compacting concrete, الخرسانة ذاتية الدمك. بطبيعة الحال التقنية هذه جديدة لذلك ما حتشوفه في 585 اوكي 1995 التكنولوجي توها بادية في اليابان اوكي. But other than that, okay, for slum, the tolerance is taken from ASTM. It is the same. They are specifying both procedure, either maximum slum or target slum, and the tolerance is the same. Okay. Well, there is one issue which I'm highlighting here, okay, which has to do with the ASTM, okay, and we heard about why, okay, the adjustment, using water for adjustment is very important to the ready mix industry, okay? So there is a very, a lot of places in the ASTM standard trying to control the impact or to do it properly. So it is a very, very complex issue, okay? How to deal with the addition of water. Here we've found with the municipality work in the past 20 years that you just cannot control the addition of water, okay, on the construction site if you give them the leeway, okay. ASTM give you the leeway if part of the mixing water is retained and it's not an open. People here take it as open. The standard allow me to add water, okay? So I said, no. We told them, well, for you to fulfill the ASTM standard is almost impossible, okay? Under our condition with the 2 hours delivery time allowed, okay? So this issue was addressed by the addition of water, okay, was prohibited, okay. This is another issue which has to do with irrelevant provision, which is the air entrainment, okay. Although Aramco sometimes specify air entrainment because their standard is American standard, okay. I don't know why, but it is there. So here in the GSO they mention something about it, but it is a brief statement, okay. But it does not make sense. They are saying that, air content in case of ordinary air-free cement. Because supposedly they are thinking that cement can be also air-trained. Air entrainment for cement is now, well, never been produced in Saudi Arabia, and even in US, it is not produced. So it doesn't make sense. It is, it is some irrelevant information, okay? Measuring materials, and this is, I take issue with ASTM on this. This is very, very detailed. I don't know what makes them come to this the compromise. Is it 2% or 3%? If it is a small amount, then you have to have some leeway. It is, and the difference is marginal, okay? So this is the GSO is very abridged version of that. It does not cover all this detail, but I'm highlighting here. It is probably too much detail, okay? Trying to accommodate somebody, okay, from the Here, it's probably not an issue if the industry and the regulatory agency and academia can agree that we can accommodate this. You don't need to have all these details. Patching plant, well, there is not much on the patching plant in GSO. There is a good coverage of patching plant requirement in ASTM. The only patching plant is talking about tolerances in GSO. Okay, but delivery. This is patching plant, the delivery, okay, this is the challenge of added water. Your delivery vehicle should have meter, and this meter should be, I mean, it is detailed that, unless you have a controller at the site, who is receiving every shipment, you just cannot control this one. So to solve this issue, okay, GSO 585 said, prohibit addition of water for the purpose of adjustment, but I think it can be done through use of, you can do the adjustment using proper dosage of admixture. This will solve the issue of adjustment because you need to have the adjustment. The only thing is that doing it using water, you have no control over it. Using admixture, you have some decent control over it. Mixer and agitator, okay. Well, similar, more detail in here, truck agitator or truck mixer, and talking about that in GSO saying that the truck should not be filled more than it is rated capacity. الطاقة اللي محطوطة عليه. The ASTM is more clear that if you use it as a truck mixer, it should not exceed 63% of the volume, and if you use it only for agitating, you can go higher. Here, unfortunately, probably they even exceed the 80% because we can see the spillage of ready mix on some of the streets, especially when they are going in ramps and all of that. So it is not, compared to what we have in ASTM, there is not much coverage in GSO. Well, here, talking about mixing and delivery, we have here central mixed concrete, and we have truck mixed concrete and no shrink mixed concrete, if I understand the term shrink mixed concrete. Truck mixed concrete is not done but even in other countries is the same thing. Instead of having a stationary mixer, okay, central mixer, they are using the truck for the purpose of mixing at the patching plant. So when they leave the patching plant, the concrete is mixed. So the advantage of truck mixing is not there, okay? And, the differentiating between truck mixer and agitator is a point of contention, okay? Because I'm sure that most of the truck which is used as truck mixing does not meet the requirement of, in terms of revolution as the truck mixer. But what they do, that they do the mixing while the ingredient is coming to the truck, and they manage to find the right solution for the homogeneity, okay, homogenizing the mix. Well, more detail we have, nothing in STM. Use of non-agitating equipment, okay. There is a lot of coverage for it in the ASTM, okay. But I don't think it is relevant. It is not being used here, okay. And I don't think we need to open the door for something in this environment. So although GSO just put a small window. If you want to use it, it's got to be based on the agreement between the two parties, and he may evoke the requirement of ASTM or put the proper control over it. Okay. Batch ticket information. Well, this is the part which is almost similar. okay, between ASTM and GSO. They did not change. The only thing, okay, which has to deal with the added water, okay, it is not there in GSO, and it is not allowed also by the municipality in Riyadh at least, okay. But there is in ASTM. There is a differentiation in the information which is mandatory and non-mandatory information. In GSO, some of the non-mandatory information, okay, they have it in the mandatory, which type of cement and minimum cement content and all of that. While it can be requested based on ASTM, but it is not automatic. So similarity is there, okay. Plant inspection, there is, and I think this is probably was not there in 1995. This requirement, given an explicit recognition that the plant should give access to the inspector and all of that. They do, or as a part of the contract, but now it is in the standard, okay? So everybody has the right to go and inspect. Well, there is no such title or clear provision في الGS. ما يعني هالموضوع هذا ايش؟ وهذا موضوع إذا كان ما في أحد يسويه، يعني جهة رقابية أخرى تسويه، very important. الشركات الكبيرة أكيد يعني they do some inspection. In the United States, some contract will have somebody stationed at the batching plant to clear it. Here, it's not normally the case. Well, this section 16, practice, test method, and reporting, okay, you have some detail about the procedure, the test method for measuring all that. It's not there in the GSO, but there is interesting, they adapt to the local practice. The local practice is that the batching plant will bring his slump cone and his cube or cylinder, and the consultant who has no knowledge of preparing the specimen will supervise, will be present during the measurement to check compliance. But the one who is going to do it are this is accommodating to local condition, which is, I think, to me, it is reasonable, because you just cannot, with the small business here, the housing market, you just cannot have a consultant at the site, but you can have engineer, okay, or an inspector just overseeing this activity. So a lot of detail in ASTM, not much in GSO, okay. This is, sample and testing of fresh concrete. The measurement of flow, okay, and this has also to do with the problem of adjustment and all of that, and remeasurement and all of that. Remeasurement is a good concept, but it is not. It's not. The issue of addition of water, okay, is contentious issue. Strength. Well, there is the there is a requirement in GSO table, but it is not from ASTM. That's the only part which was, but I could not put it in here. It is coming from European standard, okay? It's similar, but instead of using 3.5 megapascal, okay, as a tolerance for single, he's using 3 megapascal, okay? But also, if you have a running average of 3, he is saying that you should have over margin, and he's given the over margin 2 to 3 megapascal. That's the requirement. And ASTM, well, as you say, in the design, you should have the overall margin, and the compliance is more of that the average should not be less than the specified strength, and they are allowing for a single to be under by 3.5, and still it is compliant. Well, another issue which is highlighted by our lecturer is the note. Sometimes the note is very valuable to deliver a message that it is not automatic that you are going to solve this problem if you don't take precautionary measure. This has to do with the over margin. Okay, that when you design, you have to have over margin to assure that you are going to supply concrete with the proper. So this is highlights. There are some 26 or 27 notes in ASTM. There is none in GSO, which is explanatory. It's not mandatory. It's explanatory comment. Okay. Failure to meet strength requirement. Okay, it's not there in GSO, but it is understood. If it is not compliant, reject. But the problem is that strength-wise, okay, you're already taking concrete. How you are going to reject, okay, or how you are going to deal with it, it's not addressed. It is addressed in ASTM, although it is not as strict as some of the consultant will do here. Well, just completing the other section just to see where we are, okay. Keywords, okay. ASTM, I think lately they start having these keywords, okay. No such thing in GSO, okay. Annex, there is this uniformity, and the uniformity is very, very important because you need to check the uniformity of the central mixer and the uniformity of the trucks mixer, okay. And this is very important in ASTM, but it, this is activity that you don't do it, it is a link with National Ready-Mix Concrete Association that National Ready-Mix Concrete Association will certify the truck or will inspect the truck and certify that they are meeting the uniformity check. So you don't need to do it as often. You need to do it at, 6 months interval or so, or if you suspect that the uniformity is being affected. So this is annex, this is mandatory. This is appendix. Appendix showing you how to calculate the average compressive strength, so to comply with the specified compressive strength. There is nothing in the GSO. So concluding remark, okay, I took some of it and I gave it to you up front, which is GS 585. Now you've seen it. Is an abridged version, نسخة مختزلة ومختصرة من ال ASTM, بس تتفق مع ال ASTM في أشياء كثيرة, okay. There is some modification, okay. In preparing GSO 585, modification and deletion of provision in ASTM seem logical and appropriate. Just the comparison we have done that most of the irrelevant provision in the ASTM was taken out, okay. But also, it affects the completeness sometimes. They throw with it also other things, which is probably important. And also there are some new items, which is only in the last decade, like self-compacting and all of that, which is not addressed by GSO. You need to incorporate it, okay? Well, GS 585 has never been updated since adoption in 1995, okay? And this is the killer, okay? So the solution is not to have this one-time effort and then you forget about it. Have a mechanism, and I think this is what now the GSO and SASO is doing, is to make a direct link with ASTM standard, okay? And do the necessary modification, okay? Like we have seen in C150, or 1914, there is nothing, okay? So I can take ASTM and use it as it is. In ready-mix, of course, you cannot do that. The suggestion, if I heard it right, from Dr. Ahmed, that I can have like European annex with the variation, but this will make a complicated standard even more complicated. So probably it is since you have a GSO, do inside, okay, the modification, not as if you have some major modification rather than if it. So you can have a criteria if it is major or minor, if it is less than half a page or a page, probably it can have modification as attached, or if it is substantial, a lot of deletion and all of that, then the addendum is probably not going to serve the purpose. Thank you very much. I have a few minutes to spare. I thought I'm going to be slower because of the lunch, but alhamdulillah. تفضل. This is the gentleman. This is not the question. I am part of the, like you. I'm participating, making an academic presentation of what we have. But yes, I think this is what probably motivated them for this workshop. حتى التليفون جوعان.
I think I finished the question. I mean, can we unify just as SASO to have one mold? I mean, 15 by 15 by 15. Yes.
The decision at that time, was we need to have both, because each one of them has some advantage. If, for instance, the turf issue, the silver and all that is solved once and for all, then the advantage of two will go away. Okay? The advantage of the two will go, but we will need to have cash. So at that present time, I think even if it is changed, it has to comply with the ACI.
Yeah. In some areas also they are using a smaller size of cylinders, 20 by 10. I mean, 10 centi diameter by 20 centi height, which is easy to handle and more maybe practical. I mean, it's a relative, it's a relevant, I mean, we discussion.
ما عاد صار يشتغل هذا الميكروفون خلص غاز واحد. السلام عليكم. صار في ميكروفونين. This issue, I think will be a issue which SASO has to deal with it. Yes. True. Well, I think the logic here, as Dr. Ahmed mentioned, is that you don't want to make changes for the sake of changes. You only make changes if it is necessary. And judging necessary, sometimes it is convenient, not necessary. But if it is necessary, okay, I think you make the changes and pay the penalty. But the penalty is clear, you know. If you are going to go with the certification and all of that, and you have variation, it will create a problem for you in the certification and the material used for certification and the training and all of that. So it is a valid point to raise. تفضل.
يا دكتور السلام عليكم.
حياك الله. ترى مخلص جازك اوصلك.
بالنسبة دكتور، لو لاحظت في المثال اللي عرضته علينا، الستاندرد اللي هو الجلف سبيسيفيكيشن ولا الفرق بينهم كان 19 سنة.
صحيح.
19 سنة فترة ممكن يكون حصل فيها شيء كثير في المجال.
صحيح.
طيب المشكلة الأساسية اللي أنا من وجهة نظري البسيطة يعني شايفها إنه تطوير الستاندرد بالنسبة لنا هنا يعني الخطوة ثقيلة شوية.
صحيح.
وفيها عدة أسباب. أنا كمهندس مدني عضو في كذا جمعية برا، وأنا عضو في الSTM في الC9 اللي كلفني $75 أسبوعيا، بتجيني البيلوتس حقتهم، بقدر أقول رأيي.
صحيح.
وبشوف اسمي في المؤتمر بينزل مهندس محمد المصموم قال كذا كذا، وبشوف التغيير الإمباكت وأنا في بيتي.
صحيح.
قاعد.
صحيح.
لا سافرت الرياض ولا جيت جدة ولا حاجة.
صحيح. صحيح.
فالتكنولوجي ممكن تقربنا من بعض كثير. ثاني حاجة لما دخلت الكوميتي هذا ما انسألت ايش الاكسبيرينس اللي عندك، ايش الشهادة اللي عندك، اي شيء. زرت فرع ساسو في جدة وقابلت الBR، قلت له أنا عندي الفكرة الفلانية 1 2 3 وأبى أتعاون معاكم في مجالي. رد علي قال لي ايش مؤهلاتك، ايش الاكسبيرينس اللي عندك. أنا معتمد من الACI عندي 6 اعتمادات من الACI، ومعتمد من NRMCA، و5 سنين لي شغال في مشاريع الحرم. أنا بالنسبة لي شايفها طيب.
صحيح. صحيح.
بالنسبة له هو قال لي أنت ما تعتبر إكسبرت، يعني ما نقدر نستفيد من رأيك بحاجة. طيب أنت لو كل الدوكيمنت اللي عندك مبنية على إكسبرت وناس هاي كلاس في التعليم، ما نقلت اللي في السوق. السوق يعني في كل الأطياف، عندك صحيح. ناس ما هي متعلمة، عندك ناس براكتس، عندك ناس اند يوزر.
صحيح.
الحل اللي أنا شايفه لازم ساسو تبدأ توسع نفسها من ناحية التكنولوجي، بحيث إنه زي الSTM أقدر أخذ ممبرشيب بسعر رمزي، بقدر أبدي رأيي من أي مكان. هذا الشيء الثاني. الشيء الثالث إنه أنا لو بقترح شيء المفروض مهما كانت خلفيتي ينسمع.
صحيح.
وعلى كلامي ينحكم علي إنه
صحيح.
هل هذا يسوى هل هذا ما يسوى.
صحيح. صحيح.
ويعطيكم العافية.
بارك الله فيك. بارك الله فيك. أعتقد السؤال سمعه اللي جنبك.
ما دام أنا جارك يعني.
أي نعم.
ما دام ما في حد من ساسو هنا اللي يمكن
نعم.
المهندس توفيق، أنا طبعا ما أعتبر من ساسو يعني نص كذا. أولا أشكرك على ملاحظاتك، يا ريت ترسلها لنا حقيقة يعني، لأنه أنت بتقول إنه ما حد يسأل عن المؤهلات. لا، أنت عندك مؤهلات حقيقة. هو الواحد لو ما عنده مؤهلات أكيد إنه أنت الآن قدمت فيك نفسك إنه عندك المؤهلات، إذا you have something to offer. صح؟ وهذا يهمنا حقيقة. ولذلك هذا قلت قبل شوي، أتمنى من أي واحد عنده يعني، وجهتنا الدعوة للجميع يعني، إنه أي واحد يحب يشارك في لجان في فرق فنية بغض النظر عن تفاصيلها، المهم إنه يعني يدري بشيء فيما يخص الخرسانة، طبعا في جميع المواضيع، بس أنا اليوم لأن نتكلم عن الخرسانة الله يحييه يرسل لنا المعلومات. يعني إحنا نبغى نكون فرق، نبغى نكون أسلوب مختلف حقيقة. يعني إحنا الآن من 2 في إدارة جديدة هنا، إدارة الدكتور سعد القصبي، ولذلك في توجه مختلف. هذه الورش أحد علاماتها يعني. فلذلك أرجو من الجميع أرسل باللي عندك. الآن مؤقتا نستخدم الإيميل اللي استخدمته للتسجيل على الأقل حتى نقدر نرتب بشيء آخر، لكن الإيميل اللي استخدمه للتسجيل استخدمه كوسيلة. هذا بيجيني أنا حقيقة. فحشوف ملاحظاتكم ونحاول نأطرها بطريقة ما، نكون لجان، نشوف الأفكار اللي عندكم، ونحاول إن شاء الله نغير في الأسلوب وتكونوا مبسوطين يعني، وأنتم أصدقاء الخرسانة يعني.
نعم.
شكرا لكم.
لا، أعتقد في جانب آخر. أنا أعتقد أنه يعني لما نتكلم عن الACTM، الاس تي ام يعني صار لها اكثر من 100 سنه. اوكي، يعني صار السيستم متشور. انت معي؟ وقلت له يعني هو يقول لك اذا انت عندك اقتراح الله يحييك تعال وسوي البرزنتيشن عن الاقتراح حقك واقنع الناس، ولا في الاخير يطشوك. اوكي، ما عندك ما عندك هنا، حتى لو حاولنا ما عندنا يا طول العمر يعني الانفولفمنت محدوده، ما نقدر اوكي نسويها. اوكي، لذلك انا ما اعتقد، مع تقديري للكلام اللي قاله الدكتور احمد، ان احنا نقدر نسويها. تقدر تاخذ اي اس تي ستاندرد اوكي وتحط كومنت على وات فيت وات داز نوت فيت، هذه معقوله. انت معي؟ بس انك ايش موديفاي something في الاي اس تي ام، موديفاي نوت يعني شيله. اوكي، will be difficult. انت معي؟ لانك ما عندك السيت اب بحيث انك تاخذ فيدباك من everybody حتى توصل الى قرار. So go to ASTM. تفضل. اي اوكي تفضل. عطوا الميكروفون. وشو؟
يعني يكسر كونكريت ويستعمل اجريجيت في انتاج خرسانة جاهزة. مسموح؟
من المواصفة اللي شفتها هنا
يعني تسمح؟ مو مسموح.
ريسايكل، لذلك مثل ما قال ريتشارد معناه ممنوع.
cannot be allowed the recycle.
لا it's
in your SASO. My question.
Okay.
In your SASO system.
أيوة.
Can we use recycled concrete?
الحين
الموضوع
الحين اللي شو اسمه اللي موجود في المواصفة
أيوة.
ما يغطي الريسايكل.
طيب اخر شغله موضوع الكاليبريشن تبع الباتشنج بلانت. كاليبريشن غير الانسبكشن. هل في شيء بالساسو بيقول كاليبريشن مثلا مرتين بالسنه، 3 مرات بالسنه، مره واحده بالسنه؟
لا
كاليبريشن غير الانسبكشن. تعيير المجابر بطريقه اندبندنت لابراتوري يعير لك المجبر.
هذه واحده من النواقص حقت الجي اس او، ما فيها ما شفت فيها شو اسمه معلومه تحديد عن هذه. بس في الامانه اوكي في الامانه يعني هم حاطين انه مفترض انت يا البلانت اوكي انك توفيها تسويها بريادك كل 6 شهور. اوكي، وفي لما يسوون لك اخر السنه عمليه الفاليديشن او في الميكس، واحده من المعلومات اللي يجمعونها منك اللي هي الكاليبريشن سيرتيفيكت او في يور ايكويبمنت. بس في المواصفه السعوديه في المواصفه
يعني موجوده كرخصه، يعني ما نعطيه ترخيص اذا ما عمل كاليبريشن.
في التوصيات في اللجنه، ففي استماره هذا عبيت، فجمل الزملاء يعني عبونا اذا اقتراع عندهم تجمع عندنا ها هذا كان هناك فيه في ورق ما حلا دائما يجيبون اي واحد يعني هو في المجله
حياك الله.
دكتور نسخة المواصفة من البرزنتيشن
موجودة على شو اسمه ايه
على الموقع
هذه
الموقع تحولها بي دي اف اول.
ايه الله يرضى عليك.
ما تحطها باوربوينت على الموقع.
هذا هو ريموفبل. هذا ريموفبل. ورا ذاك الشرط. لو واحد حق الكاميرا، واحد حق الظاهر، واحد اوكي